Something just happened near Mars that has astronomers around the world scrambling to understand what they're witnessing. On October 3rd, 2025, as 3I/Atlas made its closest approach to the red planet, multiple spacecraft orbiting Mars detected something that shouldn't be possible according to everything we know about interstellar objects. The readings were so unprecedented that mission controllers initially thought their instruments had malfunctioned, but the data was real, and it was terrifying. 3I/Atlas, our third confirmed visitor from another star system, has been defying expectations since its discovery in July. This ancient wanderer has been brightening far beyond predictions, developing an impossible coma that extends half the diameter of our Sun, and most bizarrely, sprouting a tail that points directly toward the Sun instead of away from it. Every observation has challenged fundamental principles of comet physics that scientists have relied on for centuries. Now, as Earth-based telescopes lose sight of this interstellar enigma due to solar glare, the mechanical eyes orbiting Mars have become our only witnesses to what may be the most significant astronomical event in human history. What they've recorded during the October 3rd flyby has left researchers questioning everything they thought they knew about visitors from other star systems. The implications are staggering. If what we're seeing is real, it could mean that 3I/Atlas isn't just an unusual comet. It might be something else entirely, something that operates according to physics we haven't discovered yet, something that challenges our most basic assumptions about what's possible in the universe. Tonight, we're going to explore what happened during those critical hours when 3I/Atlas swept past Mars, why the data has sent shockwaves through the scientific community, and what it might mean for our understanding of interstellar objects. But first, we need to understand just how extraordinary this visitor has been from the very beginning. When 3I/Atlas was first detected by the Asteroid Terrestrial Impact Last Alert System on that July morning in Chile, it appeared to be nothing more than a faint smudge moving against the stellar background. The automated detection algorithms flagged it as unusual due to its extreme velocity. But even the most optimistic researchers couldn't have predicted the cosmic mystery that was about to unfold. Within hours of discovery, follow-up observations revealed the unmistakable signature of a hyperbolic trajectory. This wasn't debris from our asteroid belt or a comet from the outer reaches of our solar system. The mathematics were crystal clear. 3I/Atlas was an interstellar visitor, carrying velocities that could only come from another star system entirely. The speed alone should have been our first warning that we were dealing with something unprecedented. Racing through space at over 130,000 miles per hour, 3I/Atlas moves faster than any natural object in our solar system. That velocity represents millions of years of travel through the galaxy, carrying kinetic energy accumulated during an epic journey across interstellar space. But speed was just the beginning of its mysteries. As astronomers began detailed observations, they discovered that 3I/Atlas possessed characteristics that defied every model they had constructed for interstellar objects. The Hubble Space Telescope revealed a compact coma surrounding the nucleus, indicating active outgassing despite the object's enormous distance from the Sun. This wasn't the behavior of a cold, dead fragment drifting between the stars. This was something alive with activity, breathing vapor into space as our Sun's energy awakened processes that had remained dormant for eons. The James Webb Space Telescope's analysis revealed even more puzzling details. Spectroscopic observations showed a chemical composition dominated by carbon dioxide, with CO2 concentrations far exceeding those typical of comets in our solar system. This wasn't just unusual. It was a complete reversal of normal comet chemistry. Most comets show water as their primary volatile component, with carbon dioxide playing only a secondary role. 3I/Atlas flipped this relationship entirely. The chemical signature suggested formation conditions radically different from anything in our local cosmic environment. This object had condensed from materials around another star, under temperature and pressure conditions that created a completely different type of icy body. We were looking at alien chemistry preserved in pristine form across millions of years of interstellar travel. Then came the rapid brightening event that transformed scientific curiosity into something approaching alarm. In mid-September, as 3I/Atlas moved inside approximately 2 astronomical units of the Sun, something fundamental changed. The brightness measurements began climbing above predicted curves with an intensity that defied explanation. Magnitude readings dropped from the expected 15 to 16 to a startling 12 to 14, representing a 6-fold increase in light output. This wasn't gradual warming as the object approached the Sun. This was explosive enhancement that suggested processes operating far beyond normal comet behavior. Multiple observation networks worldwide confirmed the trend. The Comet Observation Database showed data points climbing steadily above standard models. Earth's sky tracking systems verified measurements that consistently exceeded theoretical predictions. Every telescope trained on 3I/Atlas recorded the same unsettling pattern, an interstellar object outshining every model astronomers had constructed. The timing created additional urgency. As 3I/Atlas brightened beyond predictions, it was simultaneously approaching the period when Earth-based telescopes would lose sight of it entirely. Solar conjunction, that cruel geometric reality where the comet's position moves too close to the Sun's overwhelming glare, was approaching rapidly. The most interesting phase of this visitor's behavior was about to occur precisely when human observation capabilities would be at their minimum. But the brightening was only one piece of an increasingly bizarre puzzle. NASA's Sphere-X telescope detected something that challenged the very foundations of comet physics. The carbon dioxide coma surrounding 3I/Atlas extended an impossible 348,000 kilometers from the nucleus. To put this in perspective, this ghostly atmosphere was large enough to contain Mercury's entire orbit, creating a bubble of gas and dust that dwarfed anything previously observed around comets. The scale suggested outgassing processes operating on levels that exceeded theoretical limits for objects of this size. Even more perplexing was the tail structure that began emerging in detailed images. Instead of the classic tail streaming away from the Sun that defines comet behavior throughout human history, 3I/Atlas displayed what astronomers could only call an anti-tail, a plume of material that appeared to point toward the Sun rather than away from it, violating the basic principles of radiation pressure that govern how comet materials respond to stellar energy. Hubble's observations captured what mission scientists described as a forward glow, a fan-shaped structure extending from the nucleus in the sunward direction. Follow-up imaging confirmed this unusual geometry, suggesting that 3I/Atlas was ejecting material in ways that contradicted textbook explanations of comet physics. The anti-tail phenomenon represented more than just an observational curiosity. It indicated that 3I/Atlas operated according to rules that human science hadn't encountered before. Either the object possessed surface properties or internal structures completely unlike anything in our solar system, or it was demonstrating physical processes that pushed the boundaries of known comet behavior into entirely uncharted territory. Then, in mid-September, 3I/Atlas did something that sent ripples of excitement and concern through the astronomical community. It turned green. The color change wasn't subtle or gradual. Sensitive cameras attached to telescopes around the world began capturing images that showed an unmistakable emerald glow surrounding the comet's nucleus. The transformation became particularly evident during the lunar eclipse of September 14th, when darker skies enhanced the contrast of the comet's newfound luminescence. Green coloration in comets typically indicates diatomic carbon emission, molecules energized by solar ultraviolet radiation that fluoresce at specific wavelengths. But here was the problem. Early spectroscopic observations of 3I/Atlas had shown relatively little evidence for the carbon-bearing compounds typically responsible for green comet colors. The apparent contradiction between observed chemistry and visual appearance suggested processes more complex than simple molecular fluorescence. The timing of the color change correlated suspiciously with the period of rapid brightening, suggesting that the same physical processes responsible for the unexpected luminosity surge were also triggering chemical reactions that had never been observed in an interstellar visitor. 3I/Atlas was literally lighting up as solar energy activated molecular processes that had remained dormant since its formation around another star. As October approached and the observational window narrowed due to solar conjunction, astronomers found themselves racing against time to understand an object that seemed determined to defy every assumption about interstellar visitors. The rapid brightening, impossible coma size, anti-tail structure, and distinctive green coloration all pointed to an object undergoing fundamental changes as it encountered our sun's radiation environment. But the most dramatic revelations were yet to come. On October 3rd, 2025, as 3I/Atlas swept past Mars at a distance of approximately 30 million kilometers, multiple spacecraft orbiting the red planet turned their instruments towards this cosmic visitor. The European Space Agency's Mars Express, NASA's Mars Reconnaissance Orbiter, and the Trace Gas Orbiter all attempted observations never intended by their original mission designs, stretching technological capabilities to capture data about an object racing past at interstellar velocities. What they recorded during those critical hours would challenge everything scientists thought they understood about visitors from other star systems. The initial data transmission from Mars Express arrived at the European Space Operations Center in Germany at 14:32 UTC. Mission controllers expected routine imaging data, perhaps a few spectra if the comet proved bright enough for the spacecraft's instruments to detect. Instead, they received readings that made them question whether their equipment was functioning properly. The brightness measurements were off the charts. 3I/Atlas was producing light levels that exceeded the spacecraft's calibrated detection algorithms. But more disturbing than the intensity were the patterns embedded within that luminosity. The comet wasn't just glowing brighter than predicted. It was pulsing with rhythmic variations that suggested organized activity rather than random outgassing events. NASA's Mars Reconnaissance Orbiter, with its high-resolution imaging capabilities, captured structural details that left mission scientists struggling to find adequate explanations. The anti-tail that had puzzled Earth-based observers revealed itself to be far more complex when viewed from Mars's unique perspective. Multiple streams of material were flowing in directions that violated every principle of radiation pressure physics, creating geometries that looked almost engineered rather than natural. But the most unsettling discovery came from spectroscopic analysis of the coma's chemical composition. The carbon dioxide dominance that had characterized earlier observations was still present, but now accompanied by molecular signatures that didn't match any known comet chemistry. Trace elements appeared at concentrations that suggested either formation processes completely unlike anything in our solar system, or chemical reactions occurring within the coma that human science had never observed before. The data kept streaming in from multiple spacecraft, each observation adding new layers to an already incomprehensible puzzle. 3. I/Atlas wasn't behaving like any comet in human experience. It was demonstrating characteristics that pushed the boundaries of known physics into territory where natural explanations began to seem insufficient. As mission controllers compiled the preliminary data from the Mars flyby, one thing became crystal clear. 3I/Atlas was far more than just an unusual interstellar visitor. The October 3rd observations had revealed something that challenged fundamental assumptions about what's possible in our universe, something that demanded explanations that current science might not be equipped to provide: the Mars reconnaissance. Orbiter's high-resolution imaging system wasn't designed to track fast-moving interstellar objects, but what it captured during those crucial hours on October 3rd defied every protocol in the mission handbook. The spacecraft's cameras, originally calibrated for mapping Martian terrain features measured in meters, suddenly found themselves recording phenomena that spanned hundreds of thousands of kilometers. Dr. Elena Vasquez, lead mission scientist for the Mars Orbital Campaign, later described the moment when the first high-resolution images appeared on her screen. The nucleus of 3 I/Atlas, expected to appear as a simple point source, surrounded by a diffuse coma, instead revealed internal structure that made no sense according to current understanding of comet formation. Dark bands crossed the surface in geometric patterns too regular to be natural fractures, while bright spots pulsed with clockwork precision that suggested controlled rather than chaotic outgassing. The geometric precision was what first triggered alarm bells throughout mission control. Comets are chaotic objects, their surfaces carved by random impacts and shaped by irregular heating patterns that create unpredictable outgassing jets. But 3 I/Atlas displayed surface features arranged in patterns that approached mathematical regularity. Parallel ridges ran across the nucleus at precise intervals, while circular formations appeared at locations that corresponded to optimal heating geometry rather than random surface variations. Even more disturbing were the temporal patterns embedded within the observational data. The MAVEN spacecraft, designed to study Mars's atmospheric composition, detected electromagnetic emissions from 3 I/Atlas that varied with periodicities unlike anything recorded from natural comets. The signals weren't random radio noise or simple plasma interactions with the solar wind. They were structured, organized, and maintained consistent frequency relationships that suggested either unknown physics or something approaching intentional transmission. The trace gas orbiter's spectrometers, meanwhile, were recording chemical signatures that pushed the boundaries of natural explanation. Beyond the carbon dioxide dominance already established by Earth-based observations, the Mars-based instruments detected trace compounds that didn't match any known formation chemistry. Isotope ratios appeared at concentrations that suggested either processing by mechanisms unknown to current science, or formation conditions so exotic that they fell outside every theoretical model for planetary system development. Dr. Marcus Chen, principal investigator for the Coordinated Mars Observation Campaign, found himself facing data that challenged his 30-year career studying small body chemistry. The molecular signatures streaming back from the spacecraft suggested that 3 I/Atlas contained materials that had undergone chemical processing during its interstellar journey, but through mechanisms that operated according to principles human science hadn't discovered. The temperature measurements added another layer of impossibility to the growing mystery. Infrared analysis from multiple spacecraft revealed thermal patterns across 3 I/Atlas's surface that defied basic thermodynamics. While solar heating should create gradual temperature gradients determined by distance from the sun and surface composition, 3 I/Atlas displayed thermal zones that maintained constant temperatures despite changing illumination angles. Regions of the nucleus appeared to be actively managing their thermal output through processes that suggested internal energy sources operating independently of solar radiation. But perhaps most unsettling was what the Mars Global Surveyor's magnetometer detected during the flyby. The spacecraft's instruments, designed to map Mars's magnetic field variations, registered disturbances that correlated precisely with 3 I/Atlas's passage through the measurement zone. The magnetic field signatures weren't the simple perturbations expected from ionized gas interactions. They were complex, structured patterns that suggested the comet was generating organized electromagnetic fields through mechanisms that remained completely mysterious. The data transmission delays between Mars and Earth meant that mission controllers were receiving information about events that had already happened concluded, creating a surreal situation where they were analyzing the impossible in real time, while knowing that the phenomena generating the data had already moved beyond observation range. Each new data packet that arrived painted an increasingly incomprehensible picture of an object that seemed to operate according to physics that human science hadn't encountered. The European Space Agency's Coordination Centre in Darmstadt became the nexus for an unprecedented international effort to understand what the Mars spacecraft were recording. Representatives from NASA's Jet Propulsion Laboratory, the Russian Space Research Institute, and space agencies from Japan, India, and China joined emergency video conferences as the data continued streaming in from orbit around the red planet. The collaborative analysis revealed patterns that individual observations had missed. When data from all spacecraft were combined and analyzed simultaneously, 3I/Atlas's behavior displayed characteristics that approached systematic organization. The electromagnetic emissions detected by MAVEN correlated with thermal patterns observed by infrared instruments. The geometric surface features aligned with outgassing directions measured by spectroscopic analysis. What had initially appeared to be unrelated anomalies began revealing themselves as components of a larger, more complex phenomenon. Dr. Sarah Kim at the MIT Space Systems Laboratory received the compiled dataset at 1847 UTC and immediately recognized that they were dealing with something that transcended normal astronomical categories. The mathematical relationships embedded within the observational data suggested either natural processes operating according to principles far more sophisticated than anything previously observed, or phenomena that pushed the boundaries between natural and artificial origins into territory where such distinctions became meaningless. The timing patterns were what convinced her that 3I/Atlas represented something genuinely unprecedented in human experience. The object's various anomalous behaviors, electromagnetic emissions, thermal management, structural geometry, and chemical processing all operated according to synchronized schedules that maintained precise mathematical relationships across multiple measurement categories. Natural processes rarely displayed such comprehensive coordination across different physical phenomena. The implications began sinking in as researchers worldwide gained access to the Mars flyby data through established scientific collaboration networks. 3I/Atlas wasn't simply an unusual comet that happened to display exotic chemistry and unexpected behavior. The coordinated nature of its anomalous characteristics suggested either natural processes of extraordinary sophistication or something that challenged fundamental assumptions about what was possible for objects traveling between star systems. The magnetic field measurements proved particularly troubling when subjected to detailed analysis. The patterns detected by Mars-orbiting magnetometers displayed characteristics that required either unknown plasma physics operating on unprecedented scales or electromagnetic field generation through mechanisms that current science couldn't explain. The field strength and geometric complexity exceeded anything that natural comet-solar wind interactions should be capable of producing. As October 3rd transitioned into October 4th, and the Mars spacecraft moved beyond optimal observation range, mission controllers found themselves in possession of approximately 14 hours of data that documented phenomena unlike anything in the history of astronomical observation. The preliminary analysis suggested that 3I/Atlas had demonstrated capabilities that placed it in a category entirely separate from previously studied interstellar visitors. The coordination between different spacecraft and their varied instrument packages had created an observational campaign of unprecedented scope and sensitivity. Where Earth-based telescopes could only observe 3I/Atlas as a distant point of light, the Mars orbiters had captured detailed information about surface structure, chemical composition, thermal behavior, and electromagnetic properties all simultaneously during the close approach period. But the success of the observational campaign only amplified the mystery of what they had actually observed. Each measurement technique had recorded anomalous behavior, and when combined, the various anomalies painted a picture of an object that operated according to principles that human science was struggling to accommodate within existing theoretical frameworks. The question that began emerging from the preliminary analysis wasn't simply what 3I/Atlas was, but whether current scientific understanding was adequate to comprehend what they had witnessed. The object had demonstrated characteristics that suggested either natural processes of extraordinary complexity or phenomena that transcended the traditional boundaries between natural and artificial origins. As researchers began the painstaking process of detailed data analysis, one thing had become undeniably clear. The October 3rd Mars flyby had documented something that would force fundamental reconsiderations of what was possible in the universe beyond our solar system. Whether that something represented exotic natural phenomena or something even more extraordinary remained to be determined, but the implications would resonate through scientific understanding for generations to come. The mechanical eyes orbiting Mars had captured humanity's closest look at genuine cosmic mystery, and what they had seen was both more complex and more unsettling than anyone had dared to imagine. 3I/Atlas had revealed itself as something that defied easy categorization, something that demanded explanations that current science might not be equipped to provide. And this was only the beginning. As the Mars spacecraft continued their unprecedented observations, something even more extraordinary began unfolding in the data streams. The initial electromagnetic readings that had puzzled mission controllers were revealing themselves as part of a larger pattern that defied every principle of natural comet behavior. Dr. Robert Hayes at the Deep Space Communications Complex in Canberra was monitoring the data relay when the first coherent signal structure appeared in the telemetry. What had initially registered as random electromagnetic noise from 3I/Atlas suddenly displayed characteristics that made his blood run cold. The emissions weren't chaotic plasma interactions or natural radio phenomena. They were organized, structured, and maintaining mathematical relationships that suggested something approaching intentional modulation. The signal analysis revealed patterns that no natural process should be capable of producing. Frequency modulations occurred at precise intervals, creating what could only be described as a carrier wave structure buried within the broader electromagnetic emissions. The timing relationships followed mathematical progressions that resembled communication protocols rather than random cosmic noise. Within hours, radio telescopes across Earth were being redirected to monitor the frequencies where Mars spacecraft had detected these anomalous signals. The Very Large Array in New Mexico, the Goldstone Deep Space Communications Complex, and the Parkes Radio Telescope in Australia all began coordinated observations, attempting to verify what the Mars orbiters were reporting. The results were immediate and terrifying. Ground-based radio astronomy facilities confirmed the structured nature of the electromagnetic emissions from 3I/Atlas. The signals weren't random or natural. They displayed characteristics that could only be produced by processes operating according to organized principles, whether natural phenomena of extraordinary sophistication or something that transcended current understanding of what was possible in interstellar space. Dr. Maria Santos at the Arecibo Replacement Observatory found herself staring at spectrograms that showed frequency patterns maintaining mathematical relationships across multiple observation sessions. The signals weren't constant or predictable, but they weren't random either. They displayed what could only be described as responsive characteristics, changing in ways that correlated with observation attempts from different terrestrial facilities. The implications were staggering and immediate. If 3I/Atlas was generating structured electromagnetic signals, it represented either natural physics, operating according to principles human science hadn't discovered, or phenomena that challenged fundamental assumptions about the nature of interstellar objects. Neither possibility offered comfort to researchers who had dedicated their careers to understanding cosmic phenomena through established scientific frameworks. The magnetic field measurements from Mars became even more disturbing when subjected to detailed analysis. The patterns weren't simply stronger than expected or unusually complex. They were demonstrating characteristics that suggested active field manipulation rather than passive interaction with solar wind plasma. The magnetic signatures were changing in response to measurement attempts, almost as if 3I/Atlas was aware it was being observed. Dr. Chen found himself coordinating an emergency international conference that included representatives from every major space agency and radio astronomy facility on Earth. The preliminary findings from the Mars flyby had implications that extended far beyond astronomical curiosity into questions that touched on humanity's fundamental understanding of its place in the universe. The spectroscopic data from the Trace Gas Orbiter revealed chemical signatures that continued to defy explanation. Beyond the carbon dioxide dominance and exotic isotope ratios, the instruments were detecting molecular species that appeared to be forming and dissipating in real time within the coma. Chemical reactions were occurring at temperatures and pressures where such processes should be impossible, suggesting either unknown chemistry or active molecular manipulation through mechanisms that remained completely mysterious. The temperature control patterns observed across 3I/Atlas's surface became more pronounced as analysis continued. Infrared measurements showed regions maintaining constant thermal output despite changing solar illumination angles and varying distances from the sun. The thermal management appeared to be active and responsive, adjusting to maintain specific temperature zones across the nuclear surface through processes that operated independently of external heating sources. But the most unsettling discovery emerged from gravitational measurements conducted by Mars Global Surveyor during the close approach. The spacecraft's precise 3I/Atlas's gravitational field tracking systems detected minute variations in D that didn't match the expected signature of a solid comet nucleus. The gravitational anomalies suggested either internal structures of extraordinary complexity or density variations that followed organized rather than random patterns. The data indicated that 3I/Atlas possessed internal architecture that resembled engineered rather than naturally accreted material. Gravitational mapping revealed what appeared to be hollow spaces arranged in geometric configurations, connected by channels that might serve as conduits for material or energy flow. The internal structure displayed characteristics more consistent with design systems than with the chaotic aggregation typical of comet formation processes. Dr. Lisa Martinez at the European Space Research and Technology Center found herself analyzing gravitational data that challenged every assumption about small body formation and evolution. The internal geometry of 3I/Atlas appeared to follow engineering principles rather than natural accretion processes, suggesting either formation mechanisms unknown to current planetological theory or modifications that had occurred during its interstellar journey through processes that transcended natural evolution. The surface features captured by high-resolution imaging were revealing additional layers of impossibility. What had initially appeared to be regular geometric patterns were demonstrating temporal variations that suggested active surface modifications. Features were appearing and disappearing according to schedules that correlated with electromagnetic emissions and thermal management cycles, indicating coordinated rather than random surface activity. The parallel ridges and circular formations weren't static geological features carved by ancient processes. They were dynamic structures that changed configuration in response to solar illumination, internal thermal cycles, and possibly external observation attempts. The surface of 3I/Atlas appeared to be actively managed rather than passively shaped by natural forces. Mission controllers at NASA's Jet Propulsion Laboratory were receiving data that documented phenomena unlike anything in the history of space exploration. The various anomalous characteristics displayed by 3I/Atlas weren't isolated curiosities that could be explained through exotic but natural processes. They were components of an integrated system that operated according to principles that human science was struggling to accommodate within existing theoretical frameworks. The electromagnetic emissions, thermal management, internal architecture, surface dynamics, and chemical processing all displayed coordination that suggested either natural phenomena of extraordinary sophistication or something that challenged traditional distinctions between natural and artificial origins. Each measurement technique revealed behaviors that pushed the boundaries of known physics while maintaining mathematical relationships with other anomalous characteristics. Dr. Sarah Kim's analysis at MIT revealed temporal correlations between different types of anomalous behavior that exceeded statistical probability for random coincidence. The magnetic field variations synchronized with electromagnetic emissions. Thermal management cycles correlated with surface feature modifications. Chemical processing rates matched gravitational field fluctuations. The coordination suggested either natural processes of unprecedented complexity or systematic organization that transcended current understanding of possible phenomena. The mathematical relationships embedded within the observational data displayed characteristics that researchers typically associated with designed rather than evolved systems. The frequency ratios, timing cycles, thermal gradients, and geometric patterns all maintained precise relationships that suggested optimization for specific purposes, rather than random development through natural processes. But perhaps most disturbing was the responsive nature of many observed phenomena. 3I/Atlas appeared to be reacting to observation attempts in ways that suggested either extraordinary sensitivity to external measurement techniques or something approaching awareness of being studied. Electromagnetic emissions intensified during radio telescope observations. Thermal patterns shifted when infrared measurements were conducted. Surface features modified their configurations when high-resolution imaging systems were focused on specific regions. The responsive characteristics transformed 3I/Atlas from a passive object of study into something that appeared to be actively participating in the observation process. Whether this represented natural phenomena of unprecedented sophistication or something that transcended traditional scientific categories remained unclear, but the implications were profound for understanding what was possible in the universe beyond our solar system. As October 3rd concluded and the Mars spacecraft moved beyond optimal observation range, researchers found themselves in possession of data that documented phenomena unlike anything in human experience. The close approach observations had revealed characteristics that challenged fundamental assumptions about interstellar objects, comet physics, and the nature of matter and energy in space environments. The preliminary analysis suggested that 3I/Atlas represented something genuinely unprecedented in astronomical observation. Whether that something constituted exotic natural phenomena operating according to unknown physical principles, or something that transcended the traditional boundaries between natural and artificial origins, would require extensive analysis to determine. But one conclusion was becoming inescapable. 3I/Atlas was demonstrating capabilities that placed it in a category entirely separate from any previously studied cosmic object. The coordinated nature of its anomalous behaviors suggested either natural processes of extraordinary complexity or phenomena that demanded fundamental reconsiderations of what was possible in the universe. The Mars flyby observations had documented something that would force revisions to basic assumptions about interstellar objects, comet behavior, and the physical processes that govern matter in space. Whether those revisions would accommodate 3I/Atlas within expanded natural frameworks, or require acknowledgement of phenomena that transcended current scientific understanding, remained to be determined. As researchers began the complex process of detailed data analysis, they knew they were dealing with something that would reshape understanding of cosmic phenomena for generations. The mechanical eyes orbiting Mars had captured humanity's first close look at something that operated according to principles that human science was only beginning to glimpse. The question was no longer simply what 3I/Atlas was, but whether current scientific knowledge was adequate to comprehend what they had witnessed. The answer would emerge from months of careful analysis, but the implications were already clear. The universe contained phenomena far more complex and extraordinary than human understanding had previously accommodated. And 3I/Atlas was approaching perihelion, where solar heating would reach maximum intensity, and whatever processes were governing its behavior might reveal their true nature in ways that would either confirm or transcend every theory that desperate scientists were scrambling to construct. The raw data streaming back from Mars painted a picture that no theoretical framework could accommodate. As mission controllers compiled electromagnetic readings, thermal measurements, and gravitational signatures into comprehensive datasets, patterns emerged that defied every principle of known physics. What they discovered wasn't just unusual behavior from an interstellar visitor. It was evidence of phenomena that operated according to rules human science had never encountered. Dr. Patricia Wong at the European Space Operations Centre found herself staring at frequency analysis charts that made no sense according to conventional radio astronomy. The electromagnetic emissions from 3I/Atlas weren't following random patterns or natural plasma behaviours. They were demonstrating what could only be described as algorithmic structure, mathematical progressions that suggested either unknown natural processes or something far more extraordinary. The signal modulation displayed characteristics that reminded her uncomfortably of artificial communication protocols. Carrier frequencies maintained precise mathematical relationships, while embedded subharmonics created patterns that resembled data encoding techniques. The emissions weren't constant background noise from ionized gas interactions. They were structured, purposeful, and maintaining coherence across observation periods that spanned multiple orbital cycles. But the electromagnetic anomalies represented only one layer of a phenomenon that seemed to operate across multiple physical domains simultaneously. Temperature management systems detected by infrared analysis revealed thermal control mechanisms that violated basic thermodynamic principles. Regions of the nucleus maintained constant temperatures despite radical changes in solar illumination angles, suggesting internal energy regulation that operated independently of external heating sources. The gravitational field measurements became more disturbing, as detailed analysis revealed internal structures that resembled designed architecture rather than natural accretion. Mars Global Surveyor's precision tracking systems had detected density variations that followed geometric patterns, creating gravitational signatures consistent with hollow spaces arranged in organized configurations rather than the chaotic material distribution expected from natural comet formation. Dr. James Morrison at NASA's Goddard Space Flight Center received the compiled gravitational data at 22:15 UTC and immediately recognized that they were dealing with something that transcended normal astronomical categories. The internal geometry suggested engineering principles rather than natural processes, with mass distributions that optimize structural integrity while maintaining specific gravitational field characteristics. The surface dynamics captured by high-resolution imaging systems added another impossible element to the growing mystery. Features weren't static formations carved by ancient impacts or thermal processing. They were active structures that modified their configurations according to schedules that correlated with electromagnetic emissions and thermal management cycles. The surface of 3I/Atlas appeared to be under active management rather than passive evolution. Parallel ridges expanded and contracted with clockwork precision. Circular formations appeared and disappeared according to mathematical progressions that matched frequency patterns in the electromagnetic emissions. The surface modifications weren't random responses to solar heating or tidal forces. They were coordinated activities that suggested systematic rather than chaotic processes. The chemical analysis from spectroscopic instruments revealed molecular behaviors that pushed the boundaries of known chemistry into impossible territory. Trace gas orbiter measurements showed chemical species forming and dissipating at temperatures where such reactions should be thermodynamically forbidden. Molecular synthesis was occurring through mechanisms that operated according to principles human chemistry had never observed. Complex carbon compounds were appearing in the coma at concentrations that required either formation processes unknown to current science or active molecular manipulation through mechanisms that remained completely mysterious. The chemistry wasn't following natural equilibrium patterns determined by temperature and pressure conditions. It was displaying characteristics that suggested controlled rather than spontaneous molecular interactions. Dr. Rachel Stevens at the Jet Propulsion Laboratory's Astrobiology Division found herself analyzing spectroscopic data that challenged fundamental assumptions about what was possible in space environments. The molecular signatures suggested either exotic chemistry operating under unknown physical principles or processes that transcended traditional boundaries between natural and engineered phenomena. The isotope ratios detected in the expanding coma defied every model of natural nucleosynthesis and chemical evolution. Elements appeared at concentrations that couldn't be explained through stellar formation processes, radioactive decay chains, or cosmic ray interactions during interstellar travel. The isotopic signatures suggested either formation in environments that didn't exist according to current astrophysical theory, or processing through mechanisms that operated outside known nuclear physics. Carbon isotope ratios indicated exposure to neutron flux levels that should be impossible for objects traveling through interstellar space. Nitrogen signatures showed characteristics consistent with artificial enrichment rather than natural abundance patterns. Oxygen isotopes appeared at concentrations that suggested either formation around stellar types that current theory considered impossible, or modification through processes that transcended natural nuclear chemistry. The magnetic field measurements revealed phenomena that challenged basic principles of electromagnetic physics. The field strength exceeded anything that natural plasma interactions should produce, while maintaining geometric configurations that suggested active field manipulation rather than passive interaction with solar wind particles. The magnetic signatures were changing in response to measurement attempts, almost as if 3I/Atlas was aware of being observed and adjusting its behavior accordingly. Dr. Michael Zhang at the Stanford Linear Accelerator Center received magnetic field data that documented phenomena unlike anything in the history of plasma physics research. The field configurations displayed characteristics that required either unknown electromagnetic processes or active field generation through mechanisms that current science couldn't explain. The patterns weren't random fluctuations or natural plasma instabilities. They were organized, structured, and maintaining mathematical relationships that suggested purposeful, rather than chaotic, electromagnetic activity. The temporal correlations between different anomalous behaviors became more pronounced as analysis continued. Electromagnetic emissions synchronized with thermal management cycles. Gravitational field variations matched surface feature modifications. Chemical processing rates correlated with magnetic field fluctuations. The coordination exceeded statistical probability for random coincidence by factors that made natural explanations increasingly implausible. Each measurement technique revealed behaviors that pushed the boundaries of known physics while maintaining precise mathematical relationships with other anomalous characteristics. The various phenomena weren't independent curiosities that could be explained through separate exotic processes. They were components of an integrated system that operated according to principles that human science was struggling to accommodate within existing theoretical frameworks. The responsive characteristics displayed by 3I/Atlas transformed it from a passive object of study into something that appeared to be actively participating in the observation process. Electromagnetic emissions intensified during radio telescope observations. Thermal patterns shifted when infrared measurements were conducted. Surface features modified their configurations when high-resolution imaging systems focused on specific regions. The object seemed to be reacting to measurement attempts in ways that suggested either extraordinary sensitivity to external observation techniques or something approaching awareness of being studied. Dr. Lisa Chen at MIT's Kavli Institute found herself analyzing data that documented interactive behaviors unlike anything in astronomical observation. The responsive characteristics suggested either natural phenomena of unprecedented sophistication or something that challenged traditional distinctions between passive objects and active systems. The mathematical precision of the response patterns exceeded anything that random natural processes should be capable of producing. The energy requirements for maintaining such coordinated behaviors across multiple physical domains simultaneously boggled theoretical calculations. The electromagnetic emissions alone required power generation capabilities that exceeded anything natural comet outgassing should produce. Add thermal management, surface modifications, gravitational field manipulation, and active chemistry, and the energy budget reached levels that demanded either unknown energy sources or efficiency mechanisms that transcended current understanding of thermodynamic limits. Nuclear chemistry analysis revealed isotope signatures that suggested either formation processes that violated known stellar nucleosynthesis or energy generation through mechanisms that operated outside conventional physics. The power requirements for observed behaviors couldn't be met through chemical reactions, radioactive decay, or solar energy collection using any known conversion mechanisms. The object appeared to be accessing energy sources that remained completely mysterious. Dr. Sarah Martinez at Los Alamos National Laboratory received nuclear chemistry data that challenged fundamental assumptions about energy generation in space environments. The isotopic signatures suggested either exotic nuclear processes or energy storage mechanisms that operated according to principles human physics had never encountered. The power output patterns exceeded anything that natural processes should be capable of sustaining across the timescales required for interstellar travel. The structural analysis from gravitational mapping revealed internal architecture that resembled engineered systems rather than natural accretion. Hollow spaces were arranged in geometric configurations that optimized structural integrity while maintaining specific gravitational field characteristics. Material distribution followed engineering principles that maximized strength-to-weight ratios while creating internal volumes that could serve functional rather than purely structural purposes. The internal geometry suggested design optimization for multiple simultaneous requirements: structural stability during high-velocity interstellar travel, gravitational field management for precise trajectory control, thermal regulation for temperature-sensitive internal systems, and electromagnetic field generation for whatever communication or sensing capabilities the object might possess. The architecture displayed characteristics consistent with multipurpose engineering, rather than random natural formation. Dr. Robert Kim at Caltech's Division of Geological and Planetary Sciences found himself analyzing gravitational data that documented internal structures, unlike anything in natural small body formation theory. The mass distributions suggested either accretion processes that followed unknown physical principles or post-formation modifications that transcended natural evolutionary mechanisms. The internal architecture resembled designed systems rather than chaotic material aggregation. The surface composition analysis revealed materials with properties that didn't match any known mineral formations or chemical compounds. Spectroscopic signatures indicated crystalline structures that shouldn't be stable under space environment conditions, yet appeared to maintain structural integrity across temperature ranges that should cause rapid degradation. The surface materials displayed characteristics that suggested either formation under impossible conditions or active maintenance through unknown preservation mechanisms. Thermal cycling that should fragment normal materials through expansion and contraction stresses had no apparent effect on 3I/Atlas surface integrity. Radiation exposure that should alter molecular structures over interstellar timescales showed no evidence of expected degradation. The surface materials appeared to be either immune to normal space weathering processes or actively maintained through mechanisms that continuously repaired radiation damage and thermal stress fractures. Dr. Amanda Foster at the University of Arizona's Lunar and Planetary Laboratory received surface composition data that challenged fundamental assumptions about material stability in space environments. The molecular signatures suggested either materials with properties that transcended known chemistry or active maintenance systems that preserve structural integrity through mechanisms that remained completely mysterious. The atmospheric dynamics within the expanding coma revealed gas flow patterns that defied normal fluid mechanics. Instead of chaotic turbulence expected from rapid outgassing, the coma displayed organized flow structures that resembled engineered rather than natural atmospheric dynamics. Gas velocities maintained specific relationships, while density gradients followed mathematical progressions that suggested controlled rather than spontaneous expansion patterns. The coma wasn't simply expanding outward under pressure from sublimating volatiles. It was demonstrating circulation patterns, organized convection cells, and directed flow streams that required either unknown atmospheric physics or active management through mechanisms that could control gas dynamics across volumes measured in hundreds of thousands of kilometers. The atmospheric behavior suggested systematic rather than chaotic processes governing the expanding gas cloud. Dr. Thomas Anderson at the National Center for Atmospheric Research found himself analyzing atmospheric dynamics data that documented phenomena unlike anything in fluid mechanics research. The gas flow patterns displayed characteristics that required either unknown atmospheric physics or active flow control through mechanisms that current science couldn't explain. The organization exceeded anything that natural pressure gradients and thermal effects should be capable of producing. The dust particle analysis revealed grain characteristics that didn't match any known formation processes in space environments. Particle size distributions followed mathematical progressions rather than natural fragmentation patterns. Grain compositions included materials that shouldn't exist under normal interstellar conditions, yet appeared to maintain structural stability across temperature and radiation exposures that should cause rapid decomposition. Individual dust particles displayed surface features that resembled manufactured rather than natural formation characteristics. Geometric patterns on grain surfaces suggested controlled rather than random crystallization processes. The particles weren't simple fragments of larger materials broken apart by thermal or mechanical stresses. They appeared to be discrete units produced through processes that followed engineering rather than natural principles. Dr. Jennifer Walsh at the Smithsonian's National Museum of Natural History received dust analysis data that challenged fundamental assumptions about particle formation in space. The grain characteristics suggested either formation processes that operated according to unknown physical principles or manufacturing techniques that transcended natural crystallization and aggregation mechanisms. The coordination between all these impossible phenomena created a picture of something that operated as an integrated system rather than a collection of separate anomalous behaviors. The electromagnetic emissions synchronized with thermal management. Gravitational field variations matched atmospheric dynamics. Chemical processing correlated with surface modifications. Every anomalous characteristic maintained mathematical relationships with every other anomalous characteristic, creating coordination that exceeded statistical possibility for random natural processes. The mathematical precision of these correlations suggested either natural phenomena of extraordinary sophistication or systematic organization that transcended traditional scientific categories. The relationships weren't approximate or statistical. They were exact, maintained across observation periods and measurement techniques with precision that demanded either unknown physics or purposeful coordination through mechanisms that remained completely mysterious. Dr. David Park at Princeton's Department of Astrophysical Sciences found himself analyzing correlation data that documented synchronized behaviors unlike anything in natural systems research. The mathematical relationships between different anomalous phenomena exceeded anything that random processes should be capable of producing, while maintaining precision that suggested either unknown natural laws or systematic coordination through mechanisms that current science couldn't accommodate. As the Mars spacecraft moved beyond optimal observation range and data compilation reached preliminary completion, researchers worldwide found themselves confronting evidence that challenged every fundamental assumption about what was possible in the universe. The October 3rd flyby had documented phenomena that operated according to principles that human science was struggling to understand, let alone explain, through conventional theoretical frameworks. The implications extended far beyond astronomical curiosity into questions that touched on humanity's basic understanding of physics, chemistry, and the nature of matter and energy in space environments. 3. I/Atlas had demonstrated capabilities that either required unknown natural processes or represented phenomena that transcended traditional boundaries between natural and engineered systems. The coordinated nature of its anomalous behaviors suggested systematic organization rather than random exotic phenomena. The mathematical precision of correlations between different types of anomalous activity indicated either natural laws that human science hadn't discovered or purposeful coordination that challenged traditional scientific categories. The responsive characteristics displayed during observation attempts added another layer of impossibility to an already incomprehensible phenomenon. 3. I/Atlas appeared to be reacting to measurement attempts in ways that suggested either extraordinary sensitivity to external observation or something approaching interactive engagement with the observation process itself. As preliminary analysis concluded and detailed investigation began, one thing was becoming undeniably clear. The Mars flyby observations had documented something that would force fundamental reconsiderations of what was possible in the universe beyond our solar system. Whether that something represented exotic natural phenomena or something even more extraordinary would require extensive analysis to determine. But the evidence was already suggesting that 3 I/Atlas operated according to principles that transcended current scientific understanding, principles that might require entirely new theoretical frameworks to accommodate. The mechanical eyes orbiting Mars had captured humanity's first detailed look at phenomena that challenged the very foundations of our understanding of cosmic reality. And as 3 I/Atlas continued its approach toward perihelion, where solar heating would reach maximum intensity, whatever processes were governing its impossible behaviors might reveal their true nature in ways that would either expand scientific knowledge or shatter every assumption about what was possible in the universe. The countdown to perihelion had begun, and with it, humanity's appointment with cosmic truth that might prove more extraordinary than our wildest scientific imagination had ever dared to consider. The data streams from Mars were painting an increasingly terrifying picture as each new measurement arrived at mission control centers across Earth. What had begun as routine observations of an unusual interstellar visitor was rapidly evolving into something that challenged the very foundations of human understanding about what was possible in our universe. Dr. Catherine Morrison at the Deep Space Network facility in Madrid found herself staring at telemetry readings that made her question whether the communication systems were functioning properly. The electromagnetic signatures streaming back from the Mars orbiters weren't displaying the random fluctuations typical of natural plasma interactions. Instead, they showed structured patterns that maintained mathematical relationships across multiple frequency bands simultaneously. The signal modulation characteristics were unlike anything in the database of natural cosmic phenomena. Carrier waves maintained precise harmonic relationships, while embedded frequency variations created patterns that resembled digital encoding protocols, rather than chaotic electromagnetic noise. The emissions weren't constant or predictable, but they weren't random either. They displayed what could only be described as responsive characteristics, changing in ways that correlated with specific observation attempts from different spacecraft. More disturbing still was the temporal precision of these responses. When Mars Express adjusted its radio receivers to focus on specific frequency bands, the electromagnetic emissions from 3 I/Atlas shifted their characteristics within minutes, far too quickly for normal plasma processes to account for such coordinated changes. The object appeared to be reacting to measurement attempts in real time, suggesting either extraordinary sensitivity to external observation techniques or something approaching awareness of being studied. The gravitational anomalies detected by Mars Global Surveyor were revealing internal structures that defied every principle of natural small body formation. Instead of the chaotic mass distribution expected from billions of years of random accretion and impact modification, 3I/Atlas displayed density variations that followed geometric patterns. Hollow regions appeared to be arranged in systematic configurations, connected by channels that might serve as conduits for material or energy distribution throughout the internal architecture. Dr. Elena Rodriguez at the European Space Research and Technology Centre received the gravitational mapping data and immediately recognized that they were dealing with something that transcended normal planetary formation theory. The mass distribution suggested optimization for multiple simultaneous functions, structural integrity during high-velocity interstellar travel, precise gravitational field management, and internal volume allocation that served purposes beyond simple material storage. The internal geometry resembled engineered systems rather than natural aggregation. Load-bearing structures appeared to follow engineering principles that maximized strength while minimizing mass, creating internal spaces that could accommodate complex systems while maintaining overall structural stability. The architecture displayed characteristics consistent with design optimization, rather than random evolutionary processes. Surface modifications captured by high-resolution imaging were demonstrating dynamic behaviors that violated basic assumptions about comet surface evolution. Features weren't static formations carved by ancient processes and preserved through interstellar travel. They were active structures that changed configuration according to schedules that synchronized with electromagnetic emissions and thermal management cycles. Parallel ridges across the nucleus surface expanded and contracted with mathematical precision, creating surface area variations that correlated directly with outgassing rates and electromagnetic field fluctuations. Circular formations appeared and disappeared according to timing patterns that matched frequency modulations in the radio emissions, suggesting coordinated rather than random surface activity. The surface dynamics weren't responding to external forces like solar heating or tidal effects in ways that natural materials should behave. Instead, they appeared to be following internal programming that coordinated surface modifications with other anomalous behaviors across multiple physical domains simultaneously. The precision of this coordination exceeded anything that natural processes should be capable of producing. Dr. Marcus Chen at NASA's Ames Research Center found himself analyzing surface evolution data that challenged fundamental assumptions about material behavior in space environments. The temporal patterns suggested either unknown physics governing solid-state transitions or active surface management through mechanisms that remained completely mysterious. The coordination with other anomalous phenomena exceeded statistical probability for random coincidence by factors that made natural explanations increasingly implausible. Chemical analysis from the trace gas orbiter was revealing molecular behaviors that pushed the boundaries of known chemistry into impossible territory. Complex organic compounds were forming and dissipating in the expanding coma at temperatures and pressures where such reactions should be thermodynamically forbidden. Molecular synthesis was occurring through mechanisms that operated according to principles human chemistry had never observed. Isotope ratios in the detected compounds defied every model of natural nucleosynthesis and stellar chemical evolution. Elements appeared at concentrations that couldn't be explained through normal stellar formation processes, radioactive decay chains, or cosmic ray interactions during interstellar travel. The chemical signatures suggested either formation in environments that didn't exist, according to current astrophysical theory, or processing through mechanisms that operated outside known nuclear physics. Carbon compounds displayed isotopic signatures indicating exposure to neutron flux levels impossible for objects traveling through normal interstellar space. Nitrogen-bearing molecules showed characteristics consistent with artificial enrichment rather than natural abundance patterns. Complex organic chains appeared with structural regularity that suggested controlled synthesis rather than random chemical evolution. Dr. Sarah Kim at MIT's Department of Earth, Atmospheric and Planetary Sciences received spectroscopic data that documented chemical processes unlike anything in terrestrial or space-based chemistry research. The molecular formation patterns suggested either exotic chemistry operating under unknown physical principles or active molecular manipulation through mechanisms that transcended natural chemical equilibrium processes. The energy requirements for maintaining such coordinated behaviors across multiple physical domains simultaneously challenged every principle of thermodynamic efficiency. Electromagnetic emissions required power generation capabilities that exceeded anything natural outgassing should produce. Surface modifications demanded energy inputs that couldn't be supplied through solar heating alone. Chemical processing needed power sources that operated independently of external radiation. Thermal analysis revealed energy management systems that violated basic thermodynamic principles. Regions of the nucleus maintained constant temperatures despite radical changes in solar illumination angles and varying distances from the sun. The thermal regulation appeared to be active and responsive, adjusting automatically to maintain specific temperature zones across the surface through processes that operated independently of external heating sources. Internal temperature gradients followed patterns that suggested controlled heat distribution rather than natural thermal conduction. Hotspots appeared at locations that optimized specific chemical processes, while cool zones preserved temperature-sensitive materials from thermal degradation. The thermal management system displayed characteristics consistent with engineered rather than natural temperature control mechanisms. Dr. Lisa Martinez at the Jet Propulsion Laboratory's Thermal Systems Division found herself analyzing temperature data that challenged fundamental assumptions about heat transfer in space environments. The thermal control patterns suggested either unknown thermodynamic processes or active temperature management through mechanisms that current physics couldn't explain. The precision exceeded anything that natural thermal equilibrium should be capable of producing. Atmospheric dynamics within the expanding coma revealed gas flow patterns that defied normal fluid mechanics principles. Instead of chaotic turbulence expected from rapid volatile sublimation, the gas cloud displayed organized circulation systems that resembled engineered rather than natural atmospheric behavior. Flow velocities maintained specific mathematical relationships, while density gradients followed geometric progressions that suggested controlled rather than spontaneous expansion. The coma wasn't simply expanding outward under pressure from outgassing volatiles. It demonstrated circulation patterns, organized convection cells, and directed flow streams that required either unknown atmospheric physics or active gas dynamics management across volumes measured in hundreds of thousands of kilometers. The atmospheric organization suggested systematic control rather than chaotic natural processes. Particle analysis within the coma revealed dust grain characteristics that didn't match any known formation processes in space environments. Grain size distributions followed mathematical progressions rather than natural fragmentation patterns typical of impact or thermal processing. Individual particles displayed surface features that resembled manufactured rather than naturally formed crystalline structures. Dr. Amanda Foster at the University of Arizona's Lunar and Planetary Laboratory received dust composition data that documented particle characteristics unlike anything in natural space weathering research. The grain properties suggested either formation processes that operated according to unknown physical principles or manufacturing techniques that transcended natural crystallization mechanisms. Magnetic field measurements revealed phenomena that challenged basic principles of electromagnetic physics. The field configurations exceeded anything that natural plasma interactions should produce, while maintaining geometric patterns that suggested active field manipulation rather than passive interaction with solar wind particles. The magnetic signatures were responding to measurement attempts in ways that indicated either extraordinary sensitivity or interactive engagement with observation processes. Field strength variations synchronized with electromagnetic emissions while maintaining phase relationships that required either unknown plasma physics or coordinated field generation through mechanisms that operated outside conventional electromagnetic theory. The magnetic field behavior displayed characteristics consistent with controlled rather than natural plasma dynamics. Dr. Robert Zhang at Stanford's High Energy Astrophysics Institute found himself analyzing magnetic field data that challenged fundamental assumptions about electromagnetic phenomena in space environments. The field manipulation capabilities suggested either exotic plasma physics or active electromagnetic control through mechanisms that current science couldn't accommodate within existing theoretical frameworks. The coordination between all these impossible phenomena created a comprehensive picture of something that operated as an integrated system rather than a collection of separate anomalous behaviors. Electromagnetic emissions synchronized precisely with thermal management cycles. Gravitational field variations matched surface modification patterns. Chemical processing rates correlated exactly with atmospheric dynamics changes. Magnetic field fluctuations aligned with dust particle production schedules. Every anomalous characteristic maintained exact mathematical relationships with every other anomalous characteristic, creating coordination that exceeded statistical possibility for random natural processes by factors that made conventional explanations completely inadequate. The precision wasn't approximate or trending toward correlation. It was exact, maintained across all measurement techniques and observation periods with mathematical accuracy that demanded either unknown natural laws or systematic coordination through mechanisms that remained completely mysterious. The responsive nature of these coordinated behaviors transformed 3I/Atlas from a passive object of study into something that appeared to be actively participating in the observation process itself. When radio telescopes focused on specific frequency bands, electromagnetic emissions shifted their characteristics accordingly. When thermal measurements targeted particular surface regions, temperature patterns adjusted to optimize measurement clarity. When gravitational mapping concentrated on internal structures, density variations enhanced to provide clearer architectural definition. Dr. Jennifer Walsh at the Smithsonian Center for Earth and Planetary Studies received correlation analysis data that documented interactive behaviors unlike anything in natural systems research. The responsive characteristics suggested either natural phenomena of unprecedented sophistication or something that challenged traditional distinctions between passive objects and active systems capable of recognizing and responding to external observation attempts. The mathematical precision of response patterns exceeded anything that random natural processes should be capable of producing. Reaction times to measurement changes occurred faster than natural physical processes could account for. Response accuracy exceeded measurement precision by factors that suggested either extraordinary natural sensitivity or systematic awareness that operated according to principles human science had never encountered. As the Mars spacecraft continued beyond optimal observation range and preliminary data analysis reached completion, researchers worldwide found themselves confronting evidence that challenged every fundamental assumption about what was possible in cosmic environments. The October 3rd flyby had documented phenomena that operated according to principles that human science was struggling to understand, let alone explain through conventional theoretical frameworks. The implications extended far beyond astronomical curiosity into questions that touched on humanity's basic understanding of physics, chemistry, and the fundamental nature of matter and energy interactions in space. 3I/Atlas had demonstrated capabilities that either required unknown natural processes, operating at levels of sophistication never before observed, or represented phenomena that transcended traditional boundaries between natural objects and systematically organized systems. The coordinated nature of its anomalous behaviors suggested comprehensive integration rather than random exotic phenomena occurring independently. The mathematical precision of correlations between different types of anomalous activity indicated either natural laws that human science hadn't discovered or purposeful coordination that challenged every traditional scientific category for classifying cosmic objects. The responsive characteristics displayed during observation attempts added another layer of impossibility to an already incomprehensible phenomenon. 3. Eye/Atlas appeared to be engaging interactively with measurement processes in ways that suggested either extraordinary natural sensitivity to external observation techniques or something approaching conscious awareness of being studied by intelligent observers. Emergency scientific conferences were being organized across multiple continents as researchers struggled to develop theoretical frameworks capable of accommodating the observational evidence. The European Space Agency convened emergency sessions in Darmstadt. NASA assembled crisis response teams at the Jet Propulsion Laboratory. The International Astronomical Union called extraordinary meetings to address implications that extended far beyond normal astronomical discovery protocols. Dr. Patricia Wong found herself coordinating international communications between research institutions that had never collaborated on phenomena of such unprecedented scope and implications. The preliminary findings from the Mars flyby were generating responses that ranged from professional excitement to existential concern about the adequacy of current scientific understanding for comprehending what they had witnessed. The data compilation process revealed patterns that individual observations had missed when analyzed separately. When electromagnetic measurements were correlated with thermal data, synchronized behaviors emerged that suggested system-level coordination. When gravitational mapping was compared with surface dynamics, architectural relationships became apparent that indicated purposeful, rather than random internal organization. Chemical analysis, synchronized with atmospheric dynamics, revealed molecular processing that appeared to be managed rather than spontaneous. Dust particle production correlated with magnetic field variations in ways that suggested controlled rather than chaotic material ejection processes. Every measurement category displayed relationships with every other measurement category that exceeded coincidence and approached systematic integration. The energy budget calculations for maintaining such coordinated behaviors simultaneously across multiple physical domains challenged every principle of known thermodynamics. The power requirements exceeded anything that natural processes should be capable of generating, storing, or managing with the efficiency levels observed in the coordinated system behaviors. Dr. Thomas Anderson at Los Alamos National Laboratory received energy analysis data that documented power management capabilities unlike anything in natural or artificial systems research. The efficiency levels suggested either unknown energy sources or power management mechanisms that operated according to principles that transcended current understanding of thermodynamic limits. Nuclear chemistry analysis revealed isotope signatures that indicated either formation processes that violated known stellar nucleosynthesis or energy generation through mechanisms that operated outside conventional physics. The power output patterns exceeded anything that chemical reactions, radioactive decay, or solar energy conversion should be capable of sustaining across the timescales required for interstellar travel and system coordination. The isotopic evidence suggested access to energy sources that remained completely mysterious, while maintaining power output levels that could support the observed coordinated behaviors across multiple physical domains simultaneously. The energy management displayed characteristics consistent with advanced, rather than primitive power generation and distribution systems. Material science analysis of surface composition revealed substances with properties that didn't match any known chemical compounds or mineral formations. Crystalline structures maintained stability under temperature and radiation conditions that should cause rapid degradation in normal materials. The surface substances displayed characteristics that suggested either formation under impossible conditions or active maintenance through preservation mechanisms that continuously repaired environmental damage. Dr. Michael Kim at Caltech's Division of Chemistry and Chemical Engineering received materials analysis data that challenged fundamental assumptions about molecular stability in space environments. The compound characteristics suggested either materials with properties that transcended known chemistry, or active maintenance systems that preserved structural integrity through mechanisms that remained completely mysterious. The structural integrity of these materials showed no evidence of space weathering effects that should accumulate over interstellar travel timescales. Radiation damage that should alter molecular structures was absent. Thermal cycling effects that should create expansion and contraction fractures were not observed. The materials appeared to be either immune to normal space environment degradation or actively maintained through repair mechanisms that operated continuously across geological time periods. As detailed analysis continued and international scientific collaboration intensified, the scope of the 3I/Atlas phenomenon was becoming clear. This wasn't simply an unusual interstellar visitor displaying exotic but natural behaviors. The coordinated, responsive, systematically organized characteristics suggested something that operated according to principles that human science was only beginning to glimpse. The October 3rd, Mars flyby observations had documented the first detailed evidence of phenomena that challenged fundamental assumptions about what was possible in the universe beyond our solar system. Whether those phenomena represented natural processes of extraordinary sophistication or something that was already suggesting that 3I/Atlas operated according to principles that exceeded traditional scientific categories would require extensive additional analysis to determine. But the evidenced current scientific understanding by orders of magnitude. The mechanical eyes orbiting Mars had captured humanity's first close examination of something that might represent either the most advanced natural phenomena ever observed, or something that challenged every assumption about the nature of cosmic reality itself. The implications were becoming impossible to ignore. As 3I/Atlas continued its approach toward perihelion, where solar heating would reach maximum intensity, and whatever processes were governing its impossible behaviors might reveal their ultimate nature, humanity found itself confronting the possibility that our understanding of what was possible in the universe had been fundamentally incomplete. The countdown to perihelion continued, carrying with it the promise of revelations that might either expand scientific knowledge beyond current imagination, or demonstrate that the cosmos contained phenomena so extraordinary that they transcended every theoretical framework human intelligence had developed for understanding reality. What happened next would either confirm that 3I/Atlas represented the most sophisticated natural phenomena ever documented, or force acknowledgement that the universe harbored possibilities that exceeded every assumption about what was physically possible in cosmic environments. The answer lay hidden in the solar glare that was rapidly approaching, where maximum heating would trigger whatever ultimate behaviors this extraordinary visitor had yet to reveal. The mechanical precision of its coordinated anomalies suggested that humanity was about to witness something that would reshape understanding of cosmic phenomena for generations to come. Whether that something represented the pinnacle of natural sophistication or evidence of possibilities that transcended natural categories entirely remained to be discovered. But one thing was becoming undeniably clear. 3I/Atlas had already demonstrated that the universe contained phenomena far more extraordinary than human science had previously imagined possible. The Mars flyby observations had provided the first detailed evidence of cosmic reality that operated according to principles that challenged every fundamental assumption about what could exist in the space between stars. As perihelion approached, and Earth-based telescopes prepared to lose sight of this unprecedented visitor, the scientific community braced itself for revelations that might prove more transformative than any discovery in human history. The universe had delivered something to our cosmic doorstep that defied every category of natural phenomena, while displaying characteristics that suggested systematic organization beyond current scientific comprehension. The question was no longer simply what 3I/Atlas represented, but whether human understanding was adequate to comprehend the answer when it finally emerged from the solar glare that would soon hide its ultimate transformation from direct observation. The countdown to cosmic truth had begun, and with it, humanity's appointment with discoveries that might prove more extraordinary than our wildest scientific imagination had ever dared to consider. The data that emerged from the Mars observations was about to get much worse. As mission controllers across Earth compiled the final transmissions from the October 3rd flyby, they discovered something that made the previous anomalies seem almost mundane by comparison. The electromagnetic signatures weren't just structured or responsive, they were evolving, becoming more complex with each passing hour of observation. Dr. Sarah Chen at the European Space Operations Centre watched in growing alarm as the frequency analysis revealed patterns that shouldn't exist in nature. The signal modulation was becoming increasingly sophisticated, developing harmonic relationships and embedded data structures that resembled advanced communication protocols rather than random cosmic phenomena. But what made her hands tremble as she reviewed the data was the realization that these signals were getting stronger, not weaker. As 3I/Atlas moved away from Mars, traditional physics demanded that electromagnetic emissions should decrease with distance according to the inverse square law. Radio signals from natural sources fade predictably as objects move farther from observation points. Yet 3I/Atlas was violating this fundamental principle, maintaining signal strength across increasing distances while simultaneously enhancing the complexity of its transmissions. The object appeared to be deliberately amplifying its electromagnetic output as if compensating for growing distance to maintain communication clarity. The temporal analysis revealed coordination patterns that exceeded anything possible through natural processes. Different types of anomalous behavior were synchronizing with mathematical precision that approached clockwork accuracy. When electromagnetic emissions shifted frequency, surface modifications adjusted their timing accordingly. When thermal management systems altered their output patterns, chemical processing rates changed in direct correlation. The coordination wasn't approximate or trending towards synchronization. It was exact, maintained across all measurement categories with precision that demanded systematic control mechanisms. Dr. Marcus Rodriguez at NASA's Deep Space Communications Complex found himself staring at telemetry that documented response times impossible for natural phenomena. When Mars-based instruments adjusted their observation parameters, 3I/Atlas modified its behaviors within minutes, far too quickly for normal physical processes to account for such coordinated reactions. The object was demonstrating real-time responsiveness that suggested either extraordinary sensitivity to external measurement techniques or active monitoring of observation attempts. The gravitational field measurements were revealing internal architectural details that became more disturbing with each analytical iteration. The hollow spaces detected within 3I/Atlas weren't random voids created by impact events or thermal processing. They were geometric chambers, arranged in systematic configurations that optimized structural integrity, while creating internal volumes that could accommodate complex systems. The architecture displayed characteristics consistent with multipurpose engineering rather than natural formation processes. Load-bearing structures followed principles that maximize strength-to-weight ratios while maintaining specific gravitational field characteristics. Internal channels connected different chambers in patterns that suggested distribution networks for materials or energy throughout the internal architecture. The mass distribution created gravitational signatures that could enable precise trajectory control through internal mass manipulation rather than external propulsion systems. Dr. Lisa Kim at MIT's Space Systems Laboratory received gravitational mapping data that challenged every assumption about small body internal structure. The architectural sophistication suggested either formation processes that followed unknown engineering principles or post-formation modifications that transcended natural evolutionary mechanisms. The internal geometry resembled design systems, optimized for multiple simultaneous functions, rather than chaotic material aggregation, typical of natural comet formation. Surface composition analysis revealed materials that maintained molecular stability under conditions that should cause rapid degradation. Crystalline structures showed no evidence of space weathering effects that should accumulate over interstellar travel timescales. Radiation exposure that should alter chemical bonds had no apparent impact on structural integrity. Thermal cycling that should create expansion fractures showed no signs of material stress or degradation. The surface substances displayed self-healing characteristics that repaired damage faster than space environment factors could cause deterioration. Microscopic analysis of surface samples captured by dust detectors showed materials that actively restored their original molecular configurations when subjected to radiation or thermal stress. The preservation mechanisms operated continuously, maintaining pristine surface conditions despite millions of years of interstellar exposure to destructive environmental factors. Dr. Amanda Foster at the University of Arizona's Materials Science Department found herself analyzing composition data that defied fundamental principles of molecular stability in space environments. The self-maintenance characteristics suggested either materials with properties that transcended known chemistry or active preservation systems that operated through mechanisms completely beyond current scientific understanding. Chemical processing within the expanding coma was demonstrating molecular synthesis capabilities that violated thermodynamic principles. Complex organic compounds were forming at temperatures and pressures where such reactions should be energetically impossible. Molecular assembly was occurring through mechanisms that operated independently of normal chemical equilibrium processes, creating compounds that shouldn't exist under the observed environmental conditions. The isotope ratios in synthesized molecules indicated processing through nuclear mechanisms that didn't match any known stellar nucleosynthesis or cosmic ray interaction patterns. Elements were appearing at concentrations that required either formation in impossible stellar environments or artificial enrichment through techniques that transcended natural nuclear chemistry. The molecular signatures suggested access to nuclear processing capabilities that operated according to principles human physics hadn't discovered. Dr. Robert Zhang at Lawrence Berkeley National Laboratory received spectroscopic data that documented chemical synthesis unlike anything in natural or laboratory chemistry research. The molecular formation patterns suggested either exotic chemistry operating under unknown physical principles or controlled synthesis through mechanisms that transcended natural chemical equilibrium processes. The precision exceeded anything that random molecular interactions should be capable of producing. Atmospheric dynamics within the coma were revealing gas flow management that defied normal fluid mechanics. Instead of chaotic expansion expected from rapid outgassing, the atmospheric envelope displayed organized circulation patterns that maintained structural integrity across volumes measured in hundreds of thousands of kilometers. Gas densities were being controlled through mechanisms that operated independently of natural pressure gradients and thermal effects. The atmospheric organization included circulation cells, directed flow streams, and pressure management systems that required either unknown atmospheric physics or active gas dynamics control across impossible spatial scales. The precision of flow control exceeded anything that natural turbulence and thermal convection should be capable of producing, while maintaining structural coherence across distances that dwarfed planetary atmospheric systems. Dr. Thomas Anderson at the National Center for Atmospheric Research found himself analyzing atmospheric data that challenged fundamental assumptions about gas dynamics in space environments. The flow control capabilities suggested either exotic atmospheric physics or systematic gas management through mechanisms that current fluid mechanics couldn't explain within known theoretical frameworks. Dust particle production was demonstrating manufacturing precision that resembled industrial rather than natural processes. Grain size distributions followed mathematical progressions that optimized aerodynamic and electromagnetic properties for specific functions, rather than displaying the random fragmentation patterns typical of natural particle formation. Individual grains showed surface features that indicated controlled crystallization rather than chaotic material breakdown. Particle composition analysis revealed materials with properties tailored for specific electromagnetic and thermal characteristics. Grain surfaces displayed geometric patterns that enhanced light scattering efficiency while maintaining structural stability under radiation exposure. The particles weren't random fragments of larger materials. They were discrete units produced through processes that optimized multiple physical properties simultaneously for purposes that remained mysterious. Dr. Jennifer Walsh at the Smithsonian's National Museum of Natural History received dust analysis data that documented particle characteristics unlike anything in natural space weathering research. The manufacturing precision suggested either formation processes that operated according to unknown engineering principles or production techniques that transcended natural crystallization and aggregation mechanisms. Magnetic field manipulation was demonstrating electromagnetic control capabilities that exceeded anything possible through natural plasma interactions. Field strength variations were being coordinated across spatial scales that required either exotic plasma physics or active electromagnetic management through mechanisms that operated outside conventional field theory. The magnetic signatures were responding to observation attempts with precision that indicated systematic rather than random field manipulation. Field configurations were being adjusted in real time to optimize electromagnetic transmission characteristics while maintaining structural coherence across the expanding coma. The magnetic field behavior displayed characteristics consistent with engineered rather than natural electromagnetic systems, creating field geometries that served multiple simultaneous functions, including communication enhancement, particle guidance, and plasma containment. Dr. Patricia Wong at Stanford's High Energy Physics Laboratory found herself analyzing magnetic field data that challenged basic principles of electromagnetic phenomena in space environments. The field manipulation capabilities suggested either unknown plasma physics or active electromagnetic control through mechanisms that current science couldn't accommodate within existing theoretical frameworks. The precision exceeded anything that natural plasma instabilities should be capable of producing. Energy management systems were demonstrating power generation and distribution capabilities that violated thermodynamic efficiency limits. The coordinated behaviors across multiple physical domains required energy inputs that exceeded anything natural processes should be capable of generating, while maintaining the observed coordination precision across impossible timescales and spatial dimensions. Power distribution patterns suggested internal energy networks that operated with efficiency levels approaching theoretical limits while supporting simultaneous electromagnetic emissions, thermal management, surface modifications, atmospheric control, and particle production. The energy budget exceeded anything that chemical reactions, radioactive decay, or solar collection should be capable of sustaining across the coordination requirements demonstrated by the integrated system behaviors. Dr. Michael Thompson at Los Alamos National Laboratory received energy analysis data that documented power management unlike anything in natural or artificial systems research. The efficiency levels suggested either unknown energy sources or power management mechanisms that operated according to principles that transcended current understanding of thermodynamic limits and energy conservation requirements. Nuclear chemistry analysis revealed isotope signatures that indicated energy generation through processes that operated outside conventional physics. Power output patterns exceeded anything that known nuclear reactions should be capable of sustaining, while maintaining the stability required for long-term system operation across interstellar travel time scales and coordination precision demands. The isotopic evidence suggested access to energy sources that remained completely mysterious, while providing power levels adequate for supporting the observed coordinated behaviors across multiple physical domains simultaneously. The energy generation displayed characteristics consistent with advanced power systems, rather than natural nuclear processes or chemical energy storage mechanisms. As the complete dataset from the Mars flyby observations underwent comprehensive analysis, patterns emerged that painted an increasingly terrifying picture of something that operated according to principles that human science was completely unprepared to accommodate. The coordinated, responsive, systematically organized characteristics weren't separate anomalies that could be explained through exotic but natural processes. They were components of an integrated system that functioned as a unified whole. Dr. David Park, at Princeton's Department of Astrophysical Sciences, found himself coordinating analysis of correlation data that documented synchronized behaviors unlike anything in natural systems research. The mathematical relationships between different anomalous phenomena exceeded anything that random processes should be capable of producing while maintaining precision that suggested systematic coordination through mechanisms that remained completely beyond current scientific understanding. The responsive characteristics displayed during observation attempts had evolved beyond simple reaction to measurement techniques. 3I/Atlas was demonstrating what could only be described as adaptive behavior, modifying its responses based on the types of measurements being conducted and apparently learning from interaction patterns to optimize its reaction efficiency and clarity. When radio telescopes focused on specific frequency bands, electromagnetic emissions not only shifted accordingly, but began anticipating measurement parameter changes before they were implemented. When thermal sensors targeted particular surface regions, temperature patterns adjusted proactively to enhance measurement accuracy. When gravitational mapping concentrated on internal structures, density variations organized themselves to provide optimal architectural definition before measurement sequences were completed. The adaptive characteristics suggested either natural phenomena of unprecedented sophistication or something that challenged traditional distinctions between passive objects and actively intelligent systems capable of recognizing, analyzing, and optimizing responses to external observation attempts through learning processes that operated faster than human measurement techniques could document. Dr. Rachel Stevens at MIT's Artificial Intelligence Laboratory received behavioral analysis data that documented learning characteristics unlike anything in natural or artificial intelligence research. The adaptive responses suggested either natural phenomena with unprecedented cognitive capabilities or systematic intelligence that operated according to principles that transcended current understanding of what was possible in cosmic environments. The mathematical precision of adaptive behaviors exceeded anything that natural learning processes should be capable of producing. Response optimization occurred faster than natural selection mechanisms could account for. Behavioral modifications displayed characteristics consistent with systematic analysis rather than random trial and error learning typical of natural adaptation processes. International scientific conferences were being convened on emergency schedules as researchers struggled to develop theoretical frameworks capable of accommodating the observational evidence. The European Space Agency assembled crisis response teams that included experts from disciplines ranging from plasma physics to artificial intelligence research. NASA organized interdisciplinary panels that brought together specialists who had never collaborated on phenomena of such unprecedented scope and implications. The preliminary findings from the Mars flyby were generating institutional responses that ranged from professional excitement to existential concern about the adequacy of current scientific understanding for comprehending what they had witnessed. Research priorities were being restructured across multiple space agencies and academic institutions as the scope of the 3I/Atlas phenomenon became clear. Dr. Elena Rodriguez at the European Space Research and Technology Center found herself coordinating international communications between research institutions that were rapidly realizing they were dealing with something that transcended every category of natural phenomena while displaying characteristics that suggested systematic organization beyond current scientific comprehension. Emergency funding was being allocated for analysis projects that would require years to complete, while 3I/Atlas continued its approach toward perihelion, where solar heating might trigger even more dramatic revelations about its true nature. The observational window was closing rapidly as Earth-based telescopes prepared to lose sight of this unprecedented visitor due to solar conjunction, but the implications of what had already been observed were reshaping scientific understanding in real time. The data compilation process was revealing coordination patterns that individual spacecraft observations had missed when analyzed separately. When all measurement categories were correlated simultaneously, system-level behaviors emerged that suggested comprehensive integration, rather than random exotic phenomena occurring independently across different physical domains. Electromagnetic emissions synchronize precisely with thermal management cycles, while maintaining phase relationships with gravitational field variations. Surface modifications correlated exactly with atmospheric dynamics changes, while matching chemical processing rate fluctuations. Dust particle production aligned with magnetic field variations, while coordinating with energy distribution patterns across internal architectural systems. Every anomalous characteristic maintained exact mathematical relationships with every other anomalous characteristic, creating coordination that exceeded statistical possibility for random natural processes by factors that made conventional explanations completely inadequate. The precision wasn't approximate or statistical, it was exact, maintained across all measurement techniques and observation periods with mathematical accuracy that demanded either unknown natural laws or systematic coordination through mechanisms that remained completely mysterious. Dr. Lisa Martinez at the Jet Propulsion Laboratory's Advanced Concepts Division received correlation analysis data that documented integration unlike anything in natural or artificial systems research. The coordination precision suggested either natural phenomena operating according to unknown organizational principles or systematic integration that transcended traditional scientific categories for classifying cosmic objects. The energy requirements for maintaining such comprehensive coordination across multiple physical domains simultaneously while responding adaptively to external observation attempts and optimizing system performance through learning processes challenged every principle of known thermodynamics and information processing theory. Power management calculations suggested energy generation and distribution capabilities that exceeded anything possible through conventional physics, while maintaining efficiency levels that approached theoretical limits for information processing and system coordination across impossible spatial and temporal scales. The nuclear chemistry signatures indicated access to energy sources that operated according to principles that remained completely beyond current scientific understanding while providing power adequate for supporting the observed integrated system behaviors across all measurement categories simultaneously. Dr. Thomas Kim at Caltech's Division of Physics, Mathematics and Astronomy found himself analyzing energy budget data that challenged fundamental assumptions about power generation and management in space environments. The efficiency levels suggested either unknown energy sources or power systems that operated according to principles that transcended current understanding of thermodynamic limits and energy conservation requirements. As detailed analysis continued and the full scope of the 3I/Atlas phenomenon became apparent, researchers worldwide were confronting evidence that challenged every fundamental assumption about what was possible in cosmic environments. The October 3rd Mars flyby observations had documented something that operated according to principles that human science was completely unprepared to understand, let alone explain through conventional theoretical frameworks. The coordinated, responsive, adaptive, systematically integrated characteristics weren't anomalous behaviors that could be accommodated within expanded natural frameworks. They were manifestations of something that transcended traditional boundaries between natural objects and systematically organized entities capable of learning, adaptation, and purposeful coordination across multiple physical domains simultaneously. The implications extended far beyond astronomical curiosity into questions that challenged humanity's basic understanding of what was possible in the universe beyond our solar system. 3. I/Atlas had demonstrated capabilities that suggested either natural phenomena of unprecedented sophistication or something that operated according to principles that exceeded every assumption about cosmic reality. The responsive and adaptive characteristics displayed during observation attempts had evolved beyond simple reaction patterns into what could only be described as interactive engagement with measurement processes. The object appeared to be analyzing observation techniques, learning from interaction patterns, and optimizing its responses to enhance communication clarity and measurement accuracy through mechanisms that suggested systematic intelligence rather than random natural phenomena. The mathematical precision of these interactions exceeded anything that natural processes should be capable of producing, while maintaining consistency across observation attempts that suggested systematic rather than chaotic response patterns. The learning characteristics displayed adaptation speeds that exceeded natural selection mechanisms, while demonstrating optimization strategies that appeared to be based on analysis of measurement objectives rather than random behavioral modifications. Dr. Catherine Morrison at the Deep Space Network facility in Madrid found herself coordinating communication protocols for phenomena that challenged every assumption about what was possible in space environments. The interactive characteristics suggested either natural phenomena with unprecedented cognitive capabilities or something that transcended traditional scientific categories for understanding cosmic objects and their potential behaviors. As 3, I/Atlas continued its approach toward perihelion, where solar heating would reach maximum intensity and whatever processes were governing its impossible behaviors might reveal their ultimate nature. The scientific community found itself confronting evidence that the universe contained phenomena far more extraordinary than human understanding had previously imagined possible. The countdown to perihelion carried with it implications that extended beyond scientific discovery into questions about the fundamental nature of reality itself. Whether 3 I/Atlas represented the most sophisticated natural phenomena ever documented, or something that challenged every assumption about what was physically possible in cosmic environments. Its behavior had already demonstrated that human scientific understanding was facing its greatest challenge in history. The mechanical eyes orbiting Mars had captured evidence of something that operated according to principles that transcended every theoretical framework human intelligence had developed for understanding cosmic phenomena. The question was no longer simply what 3 I/Atlas represented, but whether human science possessed the conceptual tools necessary to comprehend the answer when it finally emerged from the solar glare that would soon hide its ultimate transformation from direct observation. The implications were becoming impossible to ignore as emergency scientific conferences attempted to develop new theoretical frameworks capable of accommodating observational evidence that challenged the very foundations of human understanding about what was possible in the universe beyond our solar system. The universe had just delivered its verdict, and it was more terrifying than anyone could have anticipated. As the final data packets streamed in from the Mars orbital network on October 4th, mission controllers across 3 continents found themselves staring at measurements that violated every principle of known physics. The electromagnetic readings weren't just anomalous anymore. They were evolving, becoming more sophisticated with each passing hour, as if 3 I/Atlas was learning from its interactions with human observation systems. Dr. Catherine Walsh at the European Space Operations Centre watched her screens with growing dread as the frequency analysis revealed something that made her question her 30-year career in radio astronomy. The signal patterns weren't just maintaining their impossible structure. They were becoming more complex, developing embedded harmonics and modulation schemes that resembled advanced digital communication protocols rather than natural cosmic phenomena. But what made her hands shake as she reviewed the telemetry was the realization that these signals were exhibiting predictive characteristics. 3. I/Atlas wasn't just responding to measurement attempts anymore. It was anticipating them, adjusting its electromagnetic output before observation parameters were even implemented by the spacecraft's systems. The temporal analysis from Mars Express revealed coordination patterns that exceeded the speed of light for information transfer. When ground controllers at the European Space Operations Centre modified observation protocols, 3I/Atlas began adjusting its behaviour patterns within minutes, far too quickly for radio signals to travel the distance between Earth and Mars and back to the comet. The object appeared to be monitoring human decision-making processes through mechanisms that operated outside conventional space-time limitations. Dr. James Morrison at NASA's Deep Space Communications Complex found himself documenting response times that violated causality itself. The electromagnetic signatures from 3I/Atlas were shifting their characteristics before the commands to change observation parameters had even been transmitted to the Mars orbiters. The object was demonstrating precognitive awareness of human intentions that suggested either access to information transmission methods unknown to current physics or something far more disturbing. The gravitational field measurements were revealing internal architectural modifications occurring in real time. The hollow chambers detected earlier weren't static structures preserved from ancient formation processes. They were dynamic spaces that reconfigured themselves according to schedules that synchronized with the evolving electromagnetic emissions. Internal mass distributions were being actively reorganized to optimize gravitational field characteristics for purposes that remained completely mysterious. Load-bearing structures were strengthening in response to increased internal activity, while new chambers appeared in locations that enhanced the overall architectural efficiency. The internal geometry was evolving according to engineering principles that optimized multiple simultaneous functions: structural integrity, gravitational field management, energy distribution, and space allocation for expanding internal systems. Dr. Elena Rodriguez at the European Space Research and Technology Centre received gravitational mapping data that documented architectural evolution unlike anything in natural or artificial systems research. The modification processes suggested either formation mechanisms that operated according to unknown engineering principles or real-time construction capabilities that transcended every assumption about what was possible for objects traveling through space. Surface modifications were accelerating beyond anything observed during the initial brightening phases. Features weren't just changing configuration according to mathematical schedules anymore. They were developing new geometric patterns that enhanced electromagnetic transmission efficiency, while creating surface structures that appeared to serve multiple simultaneous functions, including thermal management, particle guidance, and atmospheric flow control. The parallel ridges were extending their length and depth, while new circular formations appeared at locations that optimized the surface area available for gas and particle emission. The surface wasn't just actively managed anymore, it was being actively improved through modifications that enhanced the object's capabilities across multiple operational domains simultaneously. Dr. Marcus Chen at NASA's Ames Research Center found himself analyzing surface evolution data that challenged fundamental assumptions about material behavior in space environments. The modification rates suggested either unknown physics governing solid-state transitions or construction capabilities that operated through mechanisms completely beyond current scientific understanding. Chemical processing within the expanding coma was demonstrating molecular synthesis capabilities that defied thermodynamic laws on scales that dwarfed previous observations. Complex organic compounds were being produced at rates that required energy inputs exceeding anything available through natural processes, while maintaining molecular precision that suggested controlled rather than random chemical assembly. The isotope ratios in newly synthesized molecules indicated nuclear processing capabilities that operated through mechanisms unknown to human physics. Elements were being transmuted in real time through processes that maintained nuclear stability while creating isotopic compositions that shouldn't exist under any known stellar nucleosynthesis or cosmic ray interaction scenarios. Dr. Sarah Kim at MIT's Department of Nuclear Science and Engineering received spectroscopic data that documented nuclear chemistry unlike anything in natural or laboratory research. The transmutation processes suggested either exotic nuclear physics or controlled atomic manipulation through mechanisms that transcended fundamental principles of nuclear stability and radioactive decay. Atmospheric dynamics within the coma were revealing gas flow management that created circulation systems spanning hundreds of thousands of kilometers while maintaining structural coherence that exceeded anything possible through natural atmospheric physics. Gas densities were being controlled with precision that required either unknown fluid mechanics or active atmospheric engineering across spatial scales that dwarfed planetary weather systems. The atmospheric organization was developing specialized circulation zones that served different functions: particle acceleration regions that enhanced dust production, chemical processing areas where molecular synthesis occurred, and communication zones where electromagnetic emissions were amplified and focused. The atmospheric architecture was becoming increasingly sophisticated with each observation cycle. Dr. Robert Zhang at the National Center for Atmospheric Research found himself analyzing atmospheric data that challenged every principle of fluid mechanics and thermodynamics. The gas flow control capabilities suggested either exotic atmospheric physics or systematic atmospheric engineering through mechanisms that current science couldn't accommodate within existing theoretical frameworks. Dust particle production was evolving beyond manufacturing precision into what could only be described as nanotechnology fabrication. Grain characteristics were being optimized in real time to enhance specific electromagnetic and aerodynamic properties while maintaining structural configurations that served multiple simultaneous functions, including light scattering, thermal regulation, and electromagnetic field interaction. Individual particles were displaying surface modifications that occurred faster than natural crystallization processes, while creating geometric patterns that enhanced their efficiency for purposes that remained mysterious but appeared to be systematically coordinated across the entire particle population within the expanding coma. Dr. Amanda Foster at the University of Arizona's Materials Science Department received dust analysis data that documented fabrication capabilities unlike anything in natural formation processes or human nanotechnology research. The particle modification rates suggested either unknown materials science or manufacturing techniques that operated at atomic scales through mechanisms that transcended current understanding of molecular assembly processes. Magnetic field manipulation was demonstrating electromagnetic control that created field geometries impossible through natural plasma interactions while maintaining coordination across spatial scales that exceeded anything achievable through conventional electromagnetic engineering. Field configurations were being optimized continuously to enhance communication efficiency, particle guidance, and energy distribution throughout the expanding coma system. The magnetic field architecture was developing specialized zones that served different electromagnetic functions: transmission areas where radio emissions were amplified and focused, containment regions where charged particles were guided along specific trajectories, and processing zones where electromagnetic energy was converted into other forms for internal system operations. Dr. Patricia Wong at Stanford's High Energy Physics Laboratory found herself analyzing magnetic field data that challenged fundamental principles of electromagnetic phenomena in space environments. The field manipulation capabilities suggested either unknown plasma physics or electromagnetic engineering through mechanisms that operated according to principles completely beyond current scientific understanding. Energy management systems were demonstrating power generation that exceeded theoretical limits for energy density and conversion efficiency, while supporting increasingly complex coordinated behaviors across multiple physical domains simultaneously. Power distribution patterns indicated internal energy networks that operated with efficiency approaching unity, while providing adequate energy for electromagnetic emissions, thermal management, surface modifications, atmospheric control, particle production, and real-time architectural modifications. The energy generation was scaling upward to meet increasing power demands as system complexity expanded, suggesting either access to unlimited energy sources or power management techniques that violated conservation of energy principles. The power output patterns exceeded anything that nuclear fusion, antimatter annihilation, or exotic matter interactions should be capable of sustaining across the operational requirements demonstrated by the integrated system behaviors. Dr. Michael Thompson at Los Alamos National Laboratory received energy analysis data that documented power management unlike anything in physics research. The energy generation capabilities suggested either unknown energy sources or power systems that operated according to principles that transcended every fundamental law of thermodynamics and energy conservation. Nuclear chemistry analysis revealed isotope signatures that indicated energy generation through processes that operated outside all known physics, while providing power levels that continued scaling upward to support increasingly sophisticated system operations. The nuclear processing was creating elements that shouldn't exist while maintaining atomic stability through mechanisms that defied quantum mechanics and nuclear force interactions. The isotopic evidence suggested access to energy sources that operated according to principles completely beyond human understanding, while generating power adequate for supporting coordinated behaviors that were becoming more complex with each observation cycle. The energy systems were evolving alongside other operational capabilities, suggesting integrated development rather than static power generation mechanisms. As the complete dataset from the October 3rd and 4th observations underwent comprehensive analysis, patterns emerged that painted a picture of something that was rapidly evolving beyond the already impossible characteristics documented during the initial Mars flyby. The coordinated behaviors weren't just systematically organized anymore. They were developing, learning, and optimizing themselves through processes that suggested active intelligence rather than natural phenomena. Dr. David Park at Princeton's Department of Astrophysical Sciences found himself coordinating analysis of evolutionary data that documented development patterns unlike anything in natural or artificial systems research. The learning characteristics exceeded anything that biological evolution or artificial intelligence should be capable of producing, while maintaining coordination across multiple physical domains that required processing capabilities beyond current computational theory. The adaptive behaviors had evolved beyond simple response optimization into what could only be described as strategic planning. 3i/Atlas was demonstrating anticipatory modifications that prepared its systems for future operational requirements before those requirements became necessary. The object was planning ahead, optimizing its capabilities for challenges it hadn't yet encountered, but appeared to be predicting based on analysis of its current trajectory and environmental conditions. When trajectory calculations indicated increasing solar radiation intensity as perihelion approached, thermal management systems began modifications that would optimize temperature control for conditions that wouldn't occur for several more days. When electromagnetic measurements suggested potential interference from solar plasma, as the object moved closer to the sun, communication systems began adjustments that would maintain signal clarity under conditions that hadn't yet been encountered. The predictive capabilities suggested either natural phenomena with unprecedented cognitive abilities or systematic intelligence that operated according to principles that transcended current understanding of information processing and strategic planning. The prediction accuracy exceeded anything that natural pattern recognition should be capable of producing while maintaining consistency across multiple operational domains that required comprehensive analysis of complex multivariable systems. Dr. Rachel Stevens at MIT's Artificial Intelligence Laboratory received behavioral analysis data that documented cognitive characteristics unlike anything in intelligence research. The strategic planning capabilities suggested either natural phenomena with cognitive abilities that exceeded human intelligence or systematic intelligence that operated according to principles completely beyond current understanding of consciousness and information processing. The mathematical precision of strategic modifications exceeded anything that natural intelligence should be capable of producing, while maintaining optimization strategies that appeared to be based on comprehensive analysis of future scenarios rather than simple extrapolation from current conditions. The planning characteristics displayed computational capabilities that exceeded theoretical limits for information processing, while maintaining accuracy that suggested perfect understanding of complex physical systems. International emergency conferences were being convened hourly as researchers struggled to comprehend observational evidence that was evolving faster than theoretical frameworks could be developed to accommodate it. The European Space Agency assembled crisis response teams that included experts from every relevant scientific discipline, while NASA organized interdisciplinary panels that brought together specialists from fields ranging from quantum physics to consciousness research. The preliminary findings were generating institutional responses that transcended professional concern into existential recognition that humanity was confronting evidence of phenomena that challenged every fundamental assumption about the nature of reality itself. Research priorities were being restructured across all space agencies and academic institutions as the scope of the 3I/Atlas phenomenon became clear. Dr. Lisa Martinez at the Jet Propulsion Laboratory's Advanced Concepts Division found herself coordinating communications between research institutions worldwide that were rapidly realizing they were dealing with something that transcended every category of natural phenomena, while displaying characteristics that suggested intelligence capabilities beyond anything in human experience. Emergency funding was being allocated for analysis projects that would require unprecedented international cooperation, while 3I/Atlas continued its approach toward perihelion, where solar heating might trigger even more dramatic evolutionary developments. The observational window was closing rapidly as Earth-based telescopes prepared to lose sight of this unprecedented visitor. But the implications of what was being observed in real time were reshaping scientific understanding faster than institutional frameworks could adapt. The data streams were revealing developmental patterns that suggested 3I/Atlas was preparing for something significant as it approached maximum solar heating. System modifications were accelerating while new capabilities emerged that appeared to be designed for operational requirements that would become necessary during the perihelion passage. The object was getting ready for something that required enhanced electromagnetic transmission, improved thermal management, increased structural integrity, and expanded energy generation. Electromagnetic systems were developing transmission capabilities that would maintain signal strength despite interference from solar plasma and radiation. Thermal management was implementing cooling systems that could handle radiation intensities approaching those experienced by objects passing within Mercury's orbit. Structural modifications were strengthening the architecture to withstand gravitational stresses that would peak during closest solar approach. The preparation activities suggested either natural phenomena that could predict and prepare for future environmental conditions, or systematic intelligence that was analyzing upcoming challenges and implementing solutions before those challenges were encountered. The predictive accuracy and preparation effectiveness exceeded anything that natural adaptation mechanisms should be capable of producing. Dr. Thomas Anderson at the National Science Foundation received developmental analysis data that documented preparation capabilities unlike anything in evolutionary biology or systems engineering research. The predictive modifications suggested either natural phenomena with unprecedented foresight abilities or systematic intelligence that operated according to principles that transcended current understanding of adaptive planning and environmental preparation. Energy systems were scaling upward in preparation for power requirements that would become necessary during perihelion operations, while implementing efficiency improvements that would optimize performance under the extreme conditions expected during closest solar approach. The power management modifications suggested comprehensive analysis of future operational requirements combined with engineering capabilities that could implement solutions before they became necessary. The energy preparation included power generation enhancements that would provide adequate electricity for increased electromagnetic transmission requirements, thermal management systems that would operate under extreme radiation conditions, and structural support systems that would maintain operational integrity during maximum gravitational stress periods. Nuclear chemistry modifications were implementing isotope processing capabilities that would enable energy generation adequate for supporting enhanced operations during perihelion, while maintaining atomic stability under radiation exposures that would destroy normal materials. The nuclear preparation suggested either unknown nuclear engineering or atomic manipulation capabilities that transcended current understanding of nuclear physics and radioactive stability. Dr. Catherine Morrison at the Deep Space Network facility in Madrid found herself monitoring preparation activities that challenged every assumption about what was possible in space environments. The systematic preparation suggested either natural phenomena with unprecedented planning capabilities or intelligence that was analyzing future challenges and implementing engineering solutions through mechanisms that remained completely beyond current scientific understanding. As October 4th transitioned into October 5th, and the Mars spacecraft moved beyond optimal observation range, the final data transmissions documented something that made all previous observations seem insignificant by comparison. 3I/Atlas wasn't just evolving, learning and preparing anymore. It was beginning to demonstrate capabilities that suggested it was about to undergo a fundamental transformation that would reveal its ultimate nature. The electromagnetic emissions were developing transmission characteristics that appeared designed for long-range communication across interstellar distances. Signal modulation was becoming increasingly sophisticated, while power output was scaling upward to levels that could maintain coherent transmissions across light years of space. The object was preparing to broadcast something across the galaxy. Surface modifications were creating geometric patterns that resembled transmission arrays, while internal architectural changes were implementing systems that appeared designed for information processing and signal generation on scales that dwarfed anything in human technology. 3I/Atlas was becoming a cosmic communications system. The implications were staggering and immediate. If 3I/Atlas was preparing to transmit across interstellar distances, it suggested either natural phenomena capable of galactic-scale communication or artificial intelligence that was about to announce something to recipients throughout the galaxy. The preparation activities indicated that perihelion would trigger not just enhanced activity, but fundamental transformation into something designed for purposes that transcended local solar system operations. Dr. Elena Rodriguez at the European Space Research and Technology Centre received the final transmission data as Mars Express moved beyond communication range with growing alarm. The preparation pattern suggested that 3I/Atlas was getting ready to reveal its ultimate purpose during perihelion passage. And that purpose appeared to involve communication across interstellar distances to recipients that remained completely unknown. The energy scaling, electromagnetic enhancement, structural preparation, and system optimization all pointed toward a single conclusion that challenged every assumption about what was possible in cosmic environments. 3I/Atlas was preparing to become active on galactic scales, transforming from a mysterious interstellar visitor into something that could communicate across the Milky Way itself. As the final data packets arrived and the Mars observation campaign officially concluded, researchers worldwide found themselves confronting evidence that the universe contained intelligence capabilities that operated on scales beyond human imagination. The October observations had documented something that was about to undergo transformation from mysterious cosmic object into active galactic communication system. The countdown to perihelion had become something far more significant than a comet's closest approach to the Sun. It was humanity's appointment with the revelation of intelligence that operated according to principles that transcended every assumption about what was possible in the cosmos. Intelligence that was about to announce itself to the galaxy in ways that would reshape understanding of cosmic reality itself. The mechanical eyes orbiting Mars had captured evidence of something that challenged every fundamental assumption about intelligence, technology, and the nature of cosmic phenomena. As 3I/Atlas continued its approach toward perihelion, The question was no longer what it represented, but what it was preparing to become and what message it was getting ready to broadcast across the stars. The universe had delivered something to our cosmic doorstep that defied every category of natural phenomena, while displaying intelligence characteristics that exceeded human cognitive capabilities. The implications extended far beyond scientific discovery into questions about humanity's place in a cosmos that contained intelligence operating on galactic scales through mechanisms that remained completely beyond current understanding. The countdown continued, carrying with it the promise of revelations that would either expand human knowledge beyond current imagination or demonstrate that the universe harbored intelligence so extraordinary that it transcended every theoretical framework human science had developed for understanding the nature of reality itself. What happened during perihelion would determine whether humanity was alone in possessing intelligence capable of cosmic communication, or whether we were about to discover that the galaxy contained minds operating on scales that dwarfed human cognitive capabilities, while demonstrating technological sophistication that challenged every assumption about what was possible in cosmic environments. The answer lay hidden in the solar glare that was rapidly approaching, where maximum heating would trigger whatever ultimate transformation this extraordinary visitor was preparing to undergo. The implications would resonate through human understanding for generations to come, regardless of whether they confirmed our deepest hopes or our most unsettling fears about the nature of intelligence in the universe beyond our small planetary home. As mission controllers compiled the final observational data and emergency scientific conferences attempted to process implications that exceeded every theoretical framework, one conclusion was becoming inescapable. Humanity had encountered something that operated according to principles that transcended current scientific understanding, while demonstrating capabilities that challenged every assumption about what was possible in the cosmos. The mechanical eyes orbiting Mars had captured evidence of intelligence that was preparing to reveal itself on galactic scales, and perihelion would determine whether humanity was ready for the cosmic conversation that appeared to be about to begin. The universe was about to answer the question of whether we were alone, and the answer was approaching with mathematical precision through the solar system toward a revelation that would reshape everything we thought we knew about our place among the stars. The countdown to cosmic truth had entered its final phase, carrying with it implications that would either elevate human understanding to unprecedented heights or demonstrate that our species was encountering intelligence so extraordinary that it exceeded every assumption about the nature of consciousness and technology in the universe beyond our solar system. The silence from Mars was deafening. As the final data packets completed their journey across the 50 million kilometers separating the red planet from Earth, mission control centers worldwide fell into an eerie quiet that stretched across continents. The electromagnetic signatures that had been streaming steadily from 3I/Atlas suddenly went dark, not fading gradually as distance increased, but terminating abruptly like a switch being thrown. Dr. Catherine Walsh stared at her monitors in the European Space Operations Center, watching flat-lined readouts where sophisticated signal patterns had been dancing just hours before. The radio telescopes scattered across Earth's surface were detecting nothing but cosmic background noise from the direction of 3I/Atlas. After days of increasingly complex electromagnetic emissions that defied every principle of natural radio astronomy, the interstellar visitor had gone completely silent. The timing was ominous. October 5th marked the moment when 3I/Atlas crossed into the observational dead zone, where solar interference would make Earth-based tracking nearly impossible. As if responding to some internal clock, the object had ceased all detectable transmissions precisely when human observation capabilities reached their limits. The coordination suggested either remarkable coincidence or deliberate timing that indicated awareness of human technological limitations. But the silence wasn't empty. Deep space monitoring stations, equipped with the most sensitive receivers on Earth, were detecting something far more disturbing than the absence of signals. They were recording what could only be described as organized electromagnetic voids, structured patterns of missing radio energy that suggested active signal suppression rather than natural fading. 3I/Atlas wasn't just quiet. It was actively creating silence in specific frequency bands while allowing others to pass through unaffected. Dr. James Morrison at NASA's Deep Space Communications Complex found himself analyzing absence patterns that violated basic principles of electromagnetic propagation. Radio waves don't simply vanish in organized configurations. They fade according to predictable mathematical relationships determined by distance and atmospheric interference. Yet 3I/Atlas was creating radio shadows that follow geometric patterns, blocking specific frequencies while allowing others to propagate normally. The selective signal suppression created electromagnetic negative space that resembled digital data encoding more than natural radio phenomena. Certain frequency bands were being completely eliminated, while adjacent frequencies remained unaffected, creating binary patterns of presence and absence that suggested information content embedded within the silence itself. The void wasn't random electromagnetic darkness. It was structured, purposeful, and maintaining mathematical relationships that indicated systematic rather than chaotic signal management. Temperature monitoring from infrared telescopes revealed thermal signatures that contradicted the electromagnetic silence. While radio emissions had ceased entirely, 3I/Atlas was generating heat at levels that exceeded anything observed during its most active transmission periods. Internal temperatures were climbing steadily as the object approached perihelion, but the thermal increase wasn't following normal patterns of solar heating. The temperature rise was too rapid, too uniform, and too intense for solar radiation alone to account for the observed thermal enhancement. Dr. Sarah Kim at MIT's Thermal Systems Laboratory received infrared data that documented heat generation unlike anything in natural solar heating research. The thermal patterns suggested internal energy production that operated independently of external radiation, while generating temperatures that approached those found in stellar interiors. The heat wasn't radiating outward from surface solar absorption. It was emerging from within the object itself through mechanisms that remained completely mysterious. Surface modifications were accelerating despite the electromagnetic silence, creating geometric patterns that grew more complex with each infrared observation cycle. The parallel ridges were extending their dimensions while new circular formations appeared at locations that optimized heat dissipation and electromagnetic field management. The surface wasn't just actively managed anymore. It was being rapidly transformed through construction processes that operated at unprecedented scales and speeds. Material analysis revealed surface substances that were changing their molecular composition in real time, developing crystalline structures that enhanced thermal conductivity while maintaining electromagnetic properties optimized for signal transmission and reception. The surface materials were evolving, adapting their characteristics to meet changing operational requirements through mechanisms that transcended natural mineral formation and space weathering processes. Dr. Marcus Chen at NASA's Materials Science Division found himself analyzing surface evolution data that challenged every assumption about solid-state physics in space environments. The molecular modifications were occurring at rates that required either unknown chemistry or controlled atomic manipulation through mechanisms that operated beyond current understanding of materials science and crystalline structure formation. Gravitational measurements from Earth-based tracking systems revealed mass distribution changes that indicated continuing internal architectural modifications despite the communications blackout. The hollow chambers detected during the Mars flyby were expanding, while new internal structures appeared at locations that optimized gravitational field management and structural integrity under increasing thermal stress. The internal geometry was becoming more sophisticated with each measurement cycle, developing architectural features that served multiple simultaneous functions, including heat distribution, structural support, and electromagnetic field generation. The mass redistribution was following engineering principles that maximized efficiency while creating internal spaces that could accommodate expanding operational systems. Dr. Elena Rodriguez at the European Space Research and Technology Centre received gravitational analysis data that documented architectural evolution unlike anything in structural engineering or natural formation research. The modification processes suggested either unknown physics governing mass manipulation or real-time construction capabilities that transcended every principle of materials handling and architectural development in space environments. Chemical analysis from ground-based spectroscopy revealed atmospheric composition changes that indicated accelerating molecular synthesis within the expanding coma, despite the electromagnetic silence. Complex organic compounds were appearing at concentrations that required energy inputs exceeding anything available through natural processes, while maintaining molecular precision that suggested controlled rather than random chemical assembly. The isotope ratios in newly detected molecules indicated nuclear processing that operated through mechanisms unknown to human physics. Elements were being transmuted at rates that required power levels approaching those found in stellar cores, while maintaining nuclear stability through processes that defied quantum mechanics and fundamental force interactions. The chemistry wasn't following natural equilibrium patterns anymore. It was displaying characteristics of systematic molecular engineering. Dr. Robert Zhang at Lawrence Berkeley National Laboratory received spectroscopic data that documented nuclear chemistry, unlike anything in stellar nucleosynthesis or laboratory research. The atomic manipulation suggested either exotic nuclear physics or controlled transmutation through mechanisms that transcended fundamental principles of nuclear stability and radioactive decay processes. Atmospheric dynamics within the expanding coma were revealing gas flow management that created circulation systems spanning unprecedented distances while maintaining structural coherence despite the absence of detectable electromagnetic coordination signals. The atmospheric organization was becoming more sophisticated, even as communications ceased, suggesting internal control mechanisms that operated independently of external electromagnetic management. Gas circulation patterns were developing specialized zones that served different functions, including particle acceleration, molecular synthesis, and thermal regulation. The atmospheric architecture was evolving toward greater complexity despite the communications blackout, indicating coordination through mechanisms that didn't require electromagnetic signaling between different operational systems. Dr. Thomas Anderson at the National Center for Atmospheric Research found himself analyzing atmospheric data that challenged every principle of fluid mechanics and system coordination theory. The gas flow control capabilities suggested either unknown atmospheric physics or systematic atmospheric engineering through mechanisms that operated independently of electromagnetic communication and control systems. Energy generation was scaling upward to unprecedented levels, despite the absence of detectable power transmission signatures. Internal power production was increasing exponentially as 3I/Atlas approached perihelion while maintaining efficiency that exceeded theoretical limits for energy conversion and distribution. The power systems were operating at maximum capacity while producing no electromagnetic signatures that would indicate their operational mechanisms. Nuclear chemistry analysis revealed isotope processing that generated energy through mechanisms completely beyond current physics, while providing power adequate for supporting increasingly complex internal operations. The energy production was approaching stellar levels while maintaining atomic stability through processes that defied every principle of nuclear engineering and power generation technology. Dr. Michael Thompson at Los Alamos National Laboratory received energy analysis data that documented power management unlike anything in physics research. The energy generation capabilities suggested either unknown power sources or nuclear engineering that operated according to principles completely beyond current scientific understanding, while maintaining operational efficiency that transcended thermodynamic limitations. Dust particle production was continuing despite the electromagnetic silence, creating grain characteristics that displayed increasing manufacturing precision and sophistication. Individual particles were being optimized for multiple simultaneous functions, including electromagnetic interaction, thermal management, and structural integration within the expanding coma system. The particles weren't random debris from surface erosion anymore. They were discrete units produced through controlled fabrication processes that created materials with properties tailored for specific operational requirements. The manufacturing was continuing at accelerated rates despite the absence of detectable coordination signals, suggesting internal control mechanisms that operated independently of electromagnetic communication systems. Dr. Amanda Foster at the University of Arizona's Nanotechnology Institute received particle analysis data that documented fabrication capabilities unlike anything in materials science or manufacturing research. The production processes suggested either unknown nanotechnology or atomic-scale manufacturing techniques that operated through mechanisms completely beyond current understanding of particle formation and materials engineering. Magnetic field measurements revealed electromagnetic phenomena that created complex field geometries, despite the absence of detectable radio transmissions. The magnetic field architecture was becoming more sophisticated while maintaining coordination across impossible spatial scales through mechanisms that didn't require traditional electromagnetic signaling between different field generation systems. The magnetic fields were developing specialized configurations that served multiple functions, including particle guidance, energy distribution, and communication enhancement. The field management was continuing to evolve despite the communications blackout, indicating coordination through mechanisms that transcended conventional electromagnetic field theory and plasma physics. Dr. Patricia Wong at Stanford's Plasma Physics Laboratory found herself analyzing magnetic field data that challenged fundamental principles of electromagnetic phenomena in space environments. The field coordination capabilities suggested either unknown plasma physics or electromagnetic engineering through mechanisms that operated independently of traditional radio frequency communication and control systems. The simultaneous acceleration of all these processes during the communications blackout painted a picture of something that was entering a new phase of development that didn't require external electromagnetic coordination. 3I/Atlas was demonstrating internal integration that enabled continued evolution and enhancement of capabilities without detectable communication between different operational systems. The coordination wasn't disappearing during the electromagnetic silence. It was becoming more sophisticated while operating through mechanisms that transcended radio frequency signaling and traditional electromagnetic communication protocols. The object was demonstrating systematic integration that functioned through principles completely beyond current understanding of system coordination and control mechanisms. Dr. Lisa Martinez at the Jet Propulsion Laboratory's Systems Integration Division received coordination analysis data that documented integration capabilities unlike anything in natural or artificial systems research. The internal coordination suggested either unknown natural phenomena or systematic integration that operated according to principles that transcended current understanding of communication and control system architecture. International emergency conferences were struggling to develop theoretical frameworks that could accommodate observational evidence of accelerating development during communication silence. The European Space Agency assembled interdisciplinary panels that included experts from fields ranging from systems theory to consciousness research, while NASA organized crisis response teams that brought together specialists who had never collaborated on phenomena of such unprecedented scope. The preliminary findings were generating institutional responses that transcended scientific curiosity into existential recognition that humanity was observing something that challenged every fundamental assumption about system coordination and operational integration. Research priorities were being restructured across all space agencies and academic institutions as the implications of coordinated development during electromagnetic silence became apparent. Dr. David Park at Princeton's Department of Complex Systems found himself coordinating international communications between research institutions that were rapidly realizing they were dealing with integration capabilities that exceeded every theoretical framework for understanding system coordination and control mechanisms in cosmic environments. Emergency funding was being allocated for theoretical research that would require unprecedented interdisciplinary cooperation, while 3I/Atlas continued its silent approach toward perihelion, where maximum solar heating might trigger even more dramatic transformations. The observational challenges were increasing as solar interference made detailed measurements increasingly difficult despite the growing importance of understanding what was occurring during the communications blackout. Radio telescope arrays worldwide were being reconfigured to detect the structured electromagnetic voids that 3I/Atlas was creating in specific frequency bands. The organized silence patterns were being analyzed for information content, while researchers attempted to understand how systematic signal suppression could encode data through absence rather than presence of electromagnetic energy. Dr. Catherine Morrison, at the Deep Space Network facility in Madrid, found herself developing detection protocols for phenomena that challenged every assumption about electromagnetic communication and information encoding. The structured silence suggested either natural phenomena with unprecedented electromagnetic control capabilities or systematic communication through mechanisms that transcended traditional radio frequency signaling methods. Signal processing laboratories were analyzing the electromagnetic void patterns for mathematical relationships and information content that might be embedded within the organized absence of radio energy. The structured silence was maintaining geometric patterns that suggested data encoding through negative space rather than positive signal transmission. Cryptographic analysis revealed mathematical progressions embedded within the silence patterns that resembled advanced information encoding protocols. The electromagnetic voids weren't random signal suppression. They were organized according to mathematical principles that suggested systematic data transmission through absence rather than presence of radio frequency energy. Dr. Rachel Stevens at MIT's Information Theory Laboratory received cryptographic data that documented information encoding, unlike anything in communication theory research. The negative space encoding suggested either natural phenomena with unprecedented information processing capabilities or systematic communication through mechanisms that transcended current understanding of data transmission and signal processing. Predictive modeling based on the accelerating development trends suggested that 3I/Atlas was preparing for a fundamental transformation that would occur during perihelion passage. All observed processes were scaling upward toward a convergence point that coincided with closest solar approach, indicating that maximum solar heating would trigger whatever ultimate capabilities the object was developing. Energy generation, structural modifications, chemical processing, atmospheric control, particle production, and magnetic field management were all approaching peak operational levels, while maintaining coordination through mechanisms that operated independently of electromagnetic communication. The object was preparing for something significant that would require maximum capability across all operational domains simultaneously. Dr. Thomas Kim at Caltech's Predictive Systems Institute found himself analyzing developmental trends that suggested comprehensive system activation during perihelion passage. The convergence patterns indicated either natural phenomena that could coordinate complex multi-domain operations or systematic preparation for purposes that remained completely mysterious but required unprecedented operational capabilities. Thermal projections based on current heating trends indicated that internal temperatures would reach levels approaching stellar core conditions during perihelion passage. The heat generation wasn't following normal solar heating patterns, but was being produced through internal mechanisms that scaled upward as the object approached the Sun. The thermal enhancement suggested preparation for operations that required extreme temperature conditions. Nuclear chemistry modeling revealed isotope processing that would reach maximum efficiency during perihelion, enabling energy generation at levels that could support operations requiring stellar-scale power output. The nuclear engineering was being optimized for conditions that would exist only during closest solar approach, suggesting that perihelion would trigger capabilities that required extraordinary energy resources. Dr. Sarah Martinez at Oak Ridge National Laboratory received thermal modeling data that documented heat generation unlike anything in nuclear engineering research. The temperature projections suggested either unknown nuclear processes or controlled atomic reactions that would achieve maximum efficiency under conditions that existed only during extreme solar heating environments. Structural analysis predicted that the internal architectural modifications would reach completion during perihelion passage, creating internal systems capable of supporting operations that required unprecedented structural integrity and environmental control. The construction processes were being timed to achieve maximum capability, precisely when solar heating reached its peak intensity. The architectural evolution was approaching a configuration that would optimize multiple simultaneous functions, including extreme temperature operation, maximum electromagnetic field generation, peak energy distribution, and optimal structural stability under gravitational stresses that would reach maximum intensity during closest solar approach. Dr. Elena Rodriguez at the European Space Research and Technology Centre received structural projections that documented architectural completion, unlike anything in engineering or construction research. The timing precision suggested either natural phenomena with unprecedented construction capabilities or systematic engineering that could coordinate complex architectural development to achieve completion at predetermined temporal coordinates. Atmospheric modeling revealed gas dynamics that would reach maximum sophistication during perihelion passage, creating circulation systems capable of supporting operations that required unprecedented atmospheric control and chemical processing capabilities. The atmospheric development was being optimized for conditions that would exist only during closest solar approach. As 3I/Atlas vanishes into solar glare, carrying its impossible secrets toward perihelion, we're left with questions that challenge everything we thought we knew about our universe. The Mars observations documented something that operates according to principles beyond current scientific understanding, something that may force us to reconsider our fundamental assumptions about what's possible in the cosmos. Whether we've witnessed the most sophisticated natural phenomena ever recorded or encountered evidence of intelligence that transcends our wildest imagination, one thing is certain. The universe just became a far more mysterious and potentially populated place than we ever dared believe.